All right, let's take a look at our practice test. For the problems today, we're going to be finding the domain. So let's move this down here. For problem 1, we have this rational expression 8x minus 4, then over 16. So when I say find the domain, what this means is find the set of allowable x values. So what am I legally allowed to plug in for x? When you work with a fraction, remember your denominator or your divisor, if you set that up as a division problem, can never be 0 because dividing by 0 is undefined in mathematics. So when I look at this problem here, this 8x minus 4 over 16, this 16 down here is a constant. It's never going to be 0. There's nothing I can plug in for x right here that's going to change that. So I can really plug in any real number I want in this problem. So my domain would be the set of real numbers. Now what I'm going to do is I'm going to write this in what we call set builder notation. If you're not familiar with that, you're just going to set up some set braces. You're going to put an x there, which means the set of all x. That's how we read that. It just means x is some real number. And then you're going to say such that, and then you're going to describe the property. So in this particular case, x is a real number. Some books would say x is an element of, and then you'd put a really fancy looking r, which I can't draw. So I'm actually not going to write it that way. I'm just going to say x is a real number like this, and then close the set braces. So the set of all x such that x is a real number just means I can plug in anything I want here for x. All right, let's look at problem 2. So now what we're looking at is 20x squared minus 8x over 8x cubed. So in this particular case, we do have values that would be excluded from the domain. If you have a variable in the denominator, like here you have this x that's being cubed, what you need to do is you actually need to take whatever's in the denominator, in this case it's 8x cubed, and you want to set it equal to 0, and you want to solve the resulting equation. Whatever solution or solutions you get, if those guys were plugged in for x in your rational expression, you would have division by 0, and therefore it would be undefined. So you need to take the step of excluding those values or that value, depending on what you get, from your domain. In this particular case, it's a very easy equation to solve. You can eyeball that and see the solutions at x equals 0. But just to make it complete, let's divide both sides by 8. So this would cancel. And let me move this over so I can fit all this one line. Then I would have x cubed is equal to, basically 0 divided by 8 is 0. And if you took the cube root of each side, well, then you'd have x is equal to 0. And you don't need all these steps. You can obviously see that x was 0 there. Let me go get rid of this. And since the solution to that equation is that x equals 0, we need to exclude 0 from the domain. And you can see if I plugged in a 0 there, 0 cubed is 0, and 0 times 8 is 0. So I would be dividing by 0, which is undefined. So what I want to do is say the set of all x such that x is not equal to 0. So that would be my domain. Anything else is legal and lawful to plug in. Okay, let's look at problem number 3. So here we have this x squared plus 9x plus 8 over x squared plus 18x plus 80. So what I'm going to do here is I'm going to take my x squared plus 18x plus 80. Again, this is my denominator. I'm going to set it equal to 0. Let me scooch this down here real quick. And then I'm just going to solve this equation. So all the equations that I'm going to give you today are things you can solve from factoring or their basic equations. So let me move this down here. How do we factor the left side of this guy? Well, remember I need an x here and an x here. And let me put the equal 0 over here. What goes here and here? Give me two integers whose sum is 18 and whose product is 80. That's going to be 10 and 8. So x plus 10 here and x plus 8 here. So we can solve this using something called the zero product property. We haven't talked about that yet in this course, but hopefully you've taken Algebra 1 already and you remember this. Basically, now that we have this guy factored, I can take each factor with a variable, set it equal to 0, and solve. So in other words, I can say x plus 10 equals 0. This would have a solution. If we subtract 10 away from each side, x is equal to negative 10. Then over here, I would say x plus 8 equals 0. And I subtract 8 away from each side, I would get x is equal to negative 8. So these two solutions, the negative 10 and the negative 8, we know that that's going to make the denominator 0, and so that's where our rational expression is going to be undefined. So let's go ahead and exclude those from the domain. Let me erase everything. So I'll say the domain is a set of all x such that x is not equal to, we had negative 10, and then we had negative 8. Go ahead and close that down. So again, basically all we're saying is that x can be any real number other than negative 10 or negative 8, because if you plug in a negative 10 or a negative 8 there, the denominator is 0 and the rational expression is undefined. All right, let's take a look at problem number 4. So we have x squared plus x minus 42, and And then this is over 3x plus 21. So let's take a look at this guy. Again, I'm just going to take whatever's in the denominator, so 3x plus 21. And I want to set this equal to 0. And I just want to solve the resulting equation. Now, you could factor a 3 out from here and make it a little bit easier. So you could say this is 3 times the quantity x plus 7 equals 0. And then I would only have to solve this part. I don't have to worry about the 3 because there's no variable involved. So all I would really have to do is say x plus 7 equals 0, subtract 7 away from each side of the equation. And essentially, I would have x is equal to negative 7. Let me put the negative over there. Again, you could have also just subtracted 21 away from each side and then divided both sides by 3. You get the same answer either way. So let's exclude negative 7 from our domain. And we will say the set of all x such that x is not equal to negative 7. Okay, let's look at problem number 5. So we have 8x plus 64 over x squared minus x minus 72. So let me scroll down a little bit. So I'll say x squared minus x minus 72. Again, I'm just setting whatever's in the denominator equal to 0. And I'm going to solve this. In this case, all of these guys are going to be factorable. If they're not factorable, we'll talk more about how to solve advanced equations as we get through the course. So I'm going to put an x here and an x here. And then I need two integers whose sum is negative 1 and whose product is negative 72. So I know I need mixed signs, so a plus and a minus. And it looks like 9 and 8 are the integers I want. And I want the larger in terms of absolute value to be negative, so I want a negative 9 and a positive 8. So again, you just solve these two equations. You're going to set this x plus 8 equal to 0 and this x minus 9 equal to 0. So x plus 8 equals 0. So subtract 8 away from each side. You'll get x is equal to negative 8. Let me scooch this over a little bit. Put a little bar here. We'll say x minus 9 equals 0. Add 9 to both sides of the equation. You get x equals 9. So again, I can't plug in a negative 8 and I can't plug in a 9 because those values make the denominator 0. So let's erase this. We'll come back up here and say the set of all x such that x is not equal to, we had negative 8 and we had positive 9. So any other real number that you want to plug in for x is good, except for these guys. Okay, let's look at problem number 6. So we have 3x squared minus 27x minus 30. This is over. We have 4x cubed minus 20x squared minus 200x. So again, let me just take this denominator. So this 4x cubed minus 20x squared minus 200x, and let me set that equal to 0. So it looks like I can pull out a 4 here, right? You have 4, you have 20, which is divisible by 4, and you have 200, which is obviously 50 times 4. So let me go ahead and pull that out. I can also pull out an x. You have x cubed, x squared, and x. So let me pull out a 4x. That would give me x squared, then minus, this would be 5x, and then minus, again, 200 divided by 4 is 50. And then close that down. We'll set that equal to 0. So now I want to factor on the inside here. Don't forget about this 4x because we're going to need that in a moment. So let me set this up like this. And I know this is x and this is x. So give me two integers whose sum is negative 5 and whose product is negative 50. I know I need opposite signs there. And it looks like I need 10 and 5. And I want a negative 10 and a positive 5. Right? That way the outer would be negative 10x. The inner would be positive 5x. That would give me my negative 5x there. Okay. So you need to set each factor with a variable equal to 0. If I had just factored out a 4, I wouldn't have to worry about this, but I factored out a 4x. So I need to set 4x equal to 0, and then I need to set x plus 5 equal to 0, and then I need to set x minus 10 equal to 0. So when you're doing this, every factor that has a variable has to be set equal to 0, and then you're going to solve the resulting equations. Okay, so this one is easy. You could divide both sides by 4 if you want to do that, but obviously the answer is x equals 0. Here I'm going to subtract 5 away from each side, x equals negative 5. And here I'm going to add 10 to both sides. You're going to get x equals 10. So you have 0, negative 5, and positive 10. So let's go ahead and say the set of all x such that x is not equal to, we'll say negative 5, 0, and then positive 10. All right, let's look at problem number 7. So we have 14x squared minus 90x minus 56. This is over 2x squared minus 7x minus 49. Scroll down just a little bit here. Again, I'm going to take my denominator. In this case, it's the 2x squared minus 7x minus 49. I'm going to set this equal to 0, and I'm going to solve the equation. Again, the things I'm giving you today, you can factor them and solve them. So let's just go ahead and set this up like this. For 2x squared, I'm going to go 2x and x. I just need to figure out this and this. And you see here that you have a subtraction. So I know I have 1 plus and 1 minus. So basically when I play with my integers, I'm going to do subtraction. So for 49, it's 1 and 49, which I would not check here. It's just not going to work. And then you have 7 and 7. So put a 7 here and a 7 here. Now my outer would be 14 and my inner would be 7. But I want a negative 7, so I want to make this a negative and this a positive. Okay, so this would be negative 14x and this would be positive 7x, which would combine to give me that correct negative 7x there. So let's set each factor equal to 0 and solve the resulting equation. So we have 2x plus 7 equals 0. We have x minus 7 equals 0. So for this one, I'm going to subtract 7 away from each side. That's going to give me 2x is equal to negative 7. Divide both sides by 2, and you're going to get that x is equal to negative 7 halves. Then over here, I'll make that 7 a little bit better, so that's more clean for your notes if you're taking them. Over here, I'm going to go plus 7 and plus 7, and that's going to give me x is equal to 7. So we get x is equal to negative 7 halves, and we get x is equal to 7. All right, so let's go ahead and say this is the set of all x such that we'll say x is not equal to the negative 7 halves, and then also the positive 7. All right, let's look at question number 8. So we're looking at 15x cubed plus 3x squared minus 12x over, we have 2x cubed minus 4x squared minus 6x. So again, I'm just going to take this denominator. So the 2x cubed minus 4x squared minus 6x, I'm going to set this equal to 0, and I'm going to solve that equation. So what you'll notice is that this is even, this is even, this is even, and everything has an x. So I could pull out a 2x here. Inside I'll have x squared minus 2x minus 3. Okay, so let this equal to 0. So what I'm going to do is set this up now as 2x times, set up these binomials. Let me move this down so I have a little bit more room. So for x squared, it's just x and x. I'm going to have opposite signs, so let me put plus and minus. So for 3, there's only 1 and 3. It's just a matter of playing with the signs here. I want the larger in terms of absolute value to be negative. So let's put the 3 here and the 1 here. So that would work out. My outer would be negative 3x. My inner would be plus x. That would give me my negative 2x that I need. If you factor this guy and you have something outside here and it has a variable, you have to take the extra step of setting that equal to 0 and solving that equation. If this was just 2, like this by itself, you would not have to do that. Obviously, it would just be 2. You don't have to worry about that. But here it's 2x. So you have to go 2x is equal to 0. Then you have to go x plus 1 is equal to 0. Then you have to go x minus 3 is equal to 0. And you have to solve these 3 equations. So obviously this is x equals 0. This one, subtract 1 away from each side, x is equal to negative 1. This one, add 3 to each side, you get x is equal to 3. So x is not going to be able to be 0, negative 1, or 3. So let's say set of all x such that x is not equal to, we had negative 1, 0, and positive 3. Let's look at problem number 9. Let me scroll down a little bit. So we have 9x plus 27 over 9x squared plus 6x minus 3. So again, I'm just taking this guy, this 9x squared, plus 6x, and then minus 3, setting it equal to 0, and solving. Now, in this case, I could pull out a 3, right? Because 9 is divisible by 3, so is 6, and so is 3. So if I pull that out, I would have 3x squared plus, this would be 2x, and then minus 1. So, and then I put this equal to 0 like this. Let me scroll down a little bit. So again, because this is a 3 on the outside, you don't need to set up an equation for that. Let me go ahead and factor this, and then I'll explain that more clearly. So for this guy, let me set this up. We'll put this as 3x and x, right? 3x times actually give me the 3x squared. I know I need opposite signs. And if I look at this negative 1 here, think about the fact that 1 can only be what? It's 1 times 1. So I can really only put a 1 here and a 1 here. The larger in terms of absolute value needs to be positive. So this is what I'm looking for here. This would be 3x minus x, which would give me the 2x that I want. So as I was just saying, again, I can't stress this enough. People get confused over this. This is just a 3 here. I don't need to set this equal to 0. That doesn't make any sense. If I had something like 3x on the outside, so if this was 3x out here, then I would set 3x equal to 0, and I would solve that. But I don't have that. I just have a 3, so you don't have to do anything with that. You just take what has a variable, those factors, and set that equal to 0. You solve those resulting equations. So 3x minus 1 equals 0. And then you also have x plus 1 equals 0. For this one, I would add 1 to each side. I would get 3x is equal to 1. Divide both sides by 3. And I would get x is equal to 1/3. Over here, I would just subtract 1 away from each side and get x is equal to negative 1. So let's erase everything and let's go ahead and set this up. So the set of all x such that x is not equal to, we'll say -1 and then 1/3. Let's take a look at problem number 10. So we have this 6x squared minus 2x minus 4. This is going to be over 7x squared minus 11x plus 4. Let me scroll down a little bit and get a little room going here. So again, I'm just going to take this 7x squared minus 11x plus 4. I'm going to set this equal to 0. On the left side, let me factor this guy. Let me set this up like this. Scroll down a little bit. So for 7, I know that's a prime number, so I can just do 7x and x here. I know that I need two negatives, right? Because this is a plus here. That can only come from a positive times a positive or a negative times a negative. And the middle guy here is negative, which comes from a negative plus a negative. So I know that each guy here is going to be negative. So I just have to think about factors of 4. You've got 4 and 1 or 2 and 2. Can I make 4 and 1 work? Well, if I put a 4 here, it's going to be way too big. 7 times 4 is 28. Again, I'm just thinking about absolute value. If I put a 4 here and a 1 here, would that work? Let me put a 4 here and a 1 here. Let me make this better here. So the outer now would be negative 7x, and the inner would be minus 4x. Negative 7x minus 4x would be negative 11x. So we're basically good to go. So I'm going to set each of these factors here equal to 0 and solve those equations. So 7x minus 4 equals 0, and then x minus 1 equals 0. Obviously, I would add 4 to both sides of the equation here. You would get 7x is equal to 4. Divide both sides by 7. And x, let me scroll down a little bit, is equal to 4/7. Here, I'm going to add 1 to both sides. We get x is equal to 1. So x is not going to be able to equal 4/7 or 1. All right, so our domain will be the set of all x such that x is not equal to, remember we had this 4/7 and positive 1. All right, let's take a look at our practice test. We're told to find the domain, or you could really say the restricted values, and to simplify. So for problem 1, we're going to look at 15x over 10x minus 10. So when you work with rational expressions, remember, you can't divide by 0. So you want to make sure that you're not plugging in something for x that gives you a denominator of 0. So to figure that out, the first thing you always do is you set your denominator equal to 0, and you solve the resulting equation. So you say 10x minus 10 is equal to 0. You're always going to do this first before you do any simplifying. And the reason for that is whenever you simplify a rational expression, in some cases, you end up with a broader domain or with less restrictions. You need to carry the restrictions over from the original rational expression you started with, the one that is non-simplified. So always do this first. So for this guy, you could solve it with factoring, or you could solve it by just, let's do it both ways. So we add 10 to both sides. You can cancel this. You'd have 10x is equal to 10, divide both sides by 10, and you would get x is equal to 1. So that's the solution. You could have also solved this using factoring. I think that's probably quicker in this case. You could pull a 10 out, and you'd have x minus 1 inside, set that equal to 0. So basically at this point, I don't need to set 10 equal to 0. I would just set x minus 1 equal to 0, and the solution for that is x equals 1. So what does this x equals 1 mean? Remember, it's telling me the value, or sometimes values, depending on how many you get, that I can't plug in for x here because it gives me a 0 as a denominator. If I plug in a 1 there, 10 times 1 is 10, and then 10 minus 10 is 0. Again, division by 0 is undefined. So you could list the restriction here by saying x is not equal to 1. You could also put the domain, depending on what your teacher wants. You could say the set of all x such that x is not equal to 1. I think for this video, just to keep things more clean, I'm going to use this notation. This is your set builder notation for a domain. You can use this also if you want. Okay, so let's get rid of this. So we've found the restricted value in this case, and now I just want to simplify. So how do I simplify a rational expression? Well, all I do, just like if I'm working with a fraction, I want to factor everything and cancel any common factors other than 1. So 15x, I think we can just leave that. You could write 5 times 3 times x if you wanted to. It's really up to you. From this guy, I'm going to pull out a 10, and inside I'm going to have my x minus 1. So let me kind of scooch this down a little bit. And let me say this is equal to, I'll go ahead and see what I can cancel. So I can cancel between 15 and 10. I can cancel a common factor of 5. 15 divided by 5 is 3. 10 divided by 5 is 2. And then that's basically it. So that gives me this 3x over, you would have this 2 times the quantity x minus 1. So a lot of times what you'll want to do, I'm just going to erase this kind of scratch work here. Let me move this down. What you want to do when you show that something's been simplified, always just list your domain. So in this case, I'm going to say that x is not equal to 1. Again, you can put this in set builder notation if you want, but I think this is good for most classes. So we're just giving our simplified version and then the restricted value here. All right, let's look at the second problem. So we have x plus 3 over, we're going to have this x squared plus 4x plus 3. All right, so again, the first thing I always want to do is figure out what is my domain or what are my restricted values. I'm going to take this denominator, x squared plus 4x plus 3. I'm going to set it equal to 0 and solve. Because we're in an early section in the course, I'm giving you things that are very easy to work with. So all of these can be solved using the factoring and then zero product property. So let's go ahead and factor this guy. So this is an x and this is an x. And obviously, if I want two integers that sum to 4 and have a product of 3, I want positive 3 and positive 1. So once you have factored this guy, remember, all you have to do is you have to take each factor with a variable, set it equal to 0, and solve that equation. Let's bring this down. So you're going to have x plus 3 is equal to 0. And then you're going to have x plus 1 is equal to 0. Let me make that a little bit better. And obviously, these are very easy equations to solve. You subtract 3 away from each side here, you get x equals negative 3. Subtract 1 away from each side of the equation here, you get x is equal to negative 1. So x cannot be negative 3 and x cannot be negative 1 because, again, those two values make the denominator 0. So let's get rid of this. And I'm just going to put a comma here and put x is not equal to negative 3 and negative 1. Okay, now I'm going to simplify. So the top part, x plus 3, I can't do anything with that. The bottom part, we just factored this, so just remember that. So this is x and this is x. This is plus 3 and this is plus 1. So I cancel common factors. This is a common source of confusion. If this makes it easier for you, wrap this in parentheses and multiply it by 1. Is this legal? Yes. This is a factor here, this quantity x plus 3, and this is a factor here, this quantity x plus 1. These are factors, right? They are multiplying by each other. So I can cancel common factors. Okay, that's very important to know. So this can be canceled with this, all right? So what does that leave me? It leaves me with a 1 up here over an x plus 1. So let me actually write this, or actually I could just erase it and make this a little bit cleaner and say this is 1 over the x plus 1 here. And then I'm just going to list my restrictions. So x cannot be equal to negative 3 and also negative 1. Now notice, if you look at this simplified rational expression, if I plugged in a negative 3 there, negative 3 plus 1 is negative 2. So I have not done anything illegal, but you have to always, always, always carry the restriction over from the original rational expression, okay? So that's what I'm talking about. If you do this out of order, you'll end up with x is not equal to negative 1 only, so you won't have all of the restricted values that you need, and your teacher's probably going to take points off on your test. So the correct answer here would be 1 over x plus 1. That's the simplified version with the restrictions that x can't be negative 3 or negative 1. All right, let's look at problem number 3. So we have x squared plus 15x plus 54 over 10x squared plus 60x. So again, take the denominator, the 10x squared plus 60x. Let's set that equal to 0. And I'm just going to pull out a 10x, and that's going to give me inside x and then plus 6. I'm going to set this equal to 0. So again, when you use this zero product property, which we'll talk about in more detail later on in the course, you're basically going to take each factor with a variable, you're going to set it equal to 0, you're going to solve that equation. So in this case, 10x is a factor. It has a variable in it, so I'm going to set it equal to 0. Then here, x plus 6, again, has a variable in it. I'm going to set that equal to 0. So here, we know x is 0, but again, for completeness, divide both sides by 10, x equals 0. Here, subtract 6 away from each side, x equals negative 6. So again, 0 and negative 6, those are your restricted values. Slide up here. I'm going to put x is not equal to 0 and then negative 6. All right, so I'm going to keep this factored version of the denominator. And now I just need to factor the numerator. So I know this is the easier case scenario. X goes here and here. So give me two integers whose sum is 15 and whose product is 54. Pretty easy, that's 9 and 6. So again, I can cancel this with this, and I'm left with x plus 9 over 10x. So you can just erase this at this point. Make this a little bit cleaner. And so we'll have x plus 9 over 10x. And again, the restrictions carry over from the original rational expression. So x cannot be 0 and it cannot be negative 6. Again, I can't stress this enough. If you did this in reverse, then what are you going to find? You would just set 10x equal to 0. You would solve that equation, and you'd find that only x can't be 0. But again, you're missing this -6 that you need because it was restricted from the original rational expression that you started with. All right, let's look at problem number 4. So we have x squared minus 12x plus 20 over x squared minus 19x plus 90. So again, I'm going to take the x squared minus 19x plus 90. That's from the denominator. I'm going to set that equal to 0, and I'm going to solve this equation. So let's go ahead and factor this guy. So I have x here and x here. Give me two integers whose sum is negative 19 and whose product is positive 90. So I know this is negative and this is negative, and I would do 9 and 10, right? Because basically negative 9 plus negative 10 is negative 19. Negative 9 times negative 10 is positive 90. All right, so from here, you would solve these two equations. Again, you would just set this up as x minus 9 equals 0. And then you also have x minus 10 equals 0. And then you can pretty much solve those mentally. You would add 9 to both sides here, so x is 9. So let's just put 9 here. And then here you would add 10 to both sides, x would be 10. Okay, so let me put 9 comma 10 here, and I'll put x is not equal to this. Let me make that a little bit better. So x is not equal to 9 or 10. Okay, so those are the values that make the denominator 0. Let me get rid of this. Let me put this like this. And then for this guy, x squared minus 12x plus 20, how can we factor this? Well, I would say x here and x here. And then let me go ahead and say, I know that it's a negative here and a positive here. So that means I'm going to have a negative and a negative. And then two integers that give me a sum of negative 12 and a product of 20. So let me think about positive factors of 20. You have 1 and 20, no. 2 and 10, yeah, I can make that work. So if it's a negative 2 and a negative 10, well then yeah, negative 2 plus negative 10 is negative 12, and then negative 2 times negative 10 is positive 20. So that's what we're looking for. And then I just want to cancel this guy with this guy, and I'm going to be left with this x minus 2 over this x minus 9. So let me move this down a little bit like this. Let me slide this down. And again, you want to carry your restriction over, so x is not equal to 9 or 10. All right, let's look at problem number 5. So we have x squared plus 4x minus 60 over 9x plus 72. So for the denominator, I have 9x plus 72, and I'm going to set that equal to 0. Now I can solve this by factoring. It's probably a little bit quicker, actually. You could pull a 9 out, and you'd have x plus 8 inside. Set this equal to 0. Again, from the zero factor property or the zero product property, however you want to talk about that, essentially you take each factor with a variable. So you would just take x plus 8 here, and you set it equal to 0, and you solve. If I had x plus 8 equals 0, you would subtract 8 away from each side, and you would get x is equal to negative 8. And the restricted value here is that x cannot be equal to negative 8. Okay, so let me factor everything. Again, we know this factors into 9 times the quantity x plus 8. Then up here, I would have this guy and this guy. So x and x. So I know I have a plus and a minus. So then you'd have to start going through the list. You would start with 1 and 60. That wouldn't work. You have 2 and 30. Wouldn't work. You have 3 and 20. Wouldn't work. 4 and 15. That wouldn't work. You'd have 5 and 12. Wouldn't work. And then you'd have 6 and 10. Now I can make 6 and 10 work if I have a negative 6 and a positive 10, right? Because basically I want my outer to be negative 6x and my inner to be positive 10x. Those combine to give me this plus 4x here. In this particular case, it doesn't work out where anything is going to cancel. You can just leave this in factored form. A lot of teachers prefer this so that you can show that nothing else is going to cancel. So this is your simplified version here, and then we'll say that x is not equal to negative 8. All right, let's look at problem number 6 now. So we have this 6x squared plus 18x minus 24. This is going to be over 21x squared minus 33x plus 12. Let's come down here a little bit. So again, I'm just going to take my denominator, 21x squared minus 33x plus 12. I'm going to set this equal to 0, and I'm going to solve this guy. Now this guy, again, I can pull out a 3, if you eyeball that, before you even get started. Inside, you'd have 7x squared minus 11x plus 4. Set that equal to 0. And let's further factor this. We can get this into the product of two binomials. So this would be 7x, and this would be x. Now for 4, you only have 1 and 4, or 2 times 2. Now this is negative here, so that tells me that both signs would be negative. Let's go ahead and put a 4 here and a 1 here. So the outer is negative 7x, the inner is negative 4x. That combines to give me the negative 11x. Okay, let me erase all this. And what you want to do is you want to set each factor with a variable equal to 0 and solve the equation. Don't worry about the 3. It's unimportant in this case. You just take the 7x minus 4, set that equal to 0. Take your x minus 1, set that equal to 0. Obviously, if you add 1 to both sides here, x is equal to 1. Here, you would have to do a little bit more work. So add 4 to both sides. That cancels. 7x is equal to 4. Divide both sides by 7. You're going to get x is equal to 4 sevenths. So 4 sevenths or 1, if you plug that into your rational expression for x, you're going to get a denominator of 0. Again, that's where it's going to be undefined. Let's put a comma. We'll put x is not equal to 4 sevenths and then also 1. Now I erase my factoring, but for the denominator, remember this factors into 3 times the quantity 7x minus 4 times the quantity x minus 1. Okay, for the numerator, let me scooch this down a little bit. For the numerator, I could pull out a 6 before I even start this. That would give me x squared plus 3x minus 4 inside. So this guy, I'd have a 6 on the outside. I'd have 2 binomials here. I'd have an x here and an x here. 2 integers that sum to 3 but have a product of negative 4. It's pretty easy. You would do a positive 4 and a negative 1. So let's move this down. Let's scooch this down. And then let's cancel common factors. So again, these guys are factors, these guys that are wrapped in parentheses. So this quantity here of x minus 1 will cancel with this quantity of x minus 1 down here. These are common factors. They can be canceled. Also have a common factor of 3 because 6 is 3 times 2 and 3 is, you can think about it as 3 times 1. It's really a prime number. But I can cancel 6 divided by 3 is 2 and 3 divided by 3 is 1. So I can really just erase this and get rid of this and this. And I'll just write this as 2 times the quantity x plus 4, then over my 7x minus 4 like this. So this would be my simplified version. And then my restrictions always come from, again, the original rational expression. So I'd say x is not equal to 4 sevenths and also positive 1. All right, let's look at problem number 7. So we have 5x minus 45. This is going to be over negative 10x cubed plus 100x squared minus 90x. So let's work on the denominator. Again, I want to do negative 10x cubed plus 100x squared minus 90x. And I want to set that equal to 0. Again, so I can find the solutions, and those are going to be my restricted values. So in this case, it looks like I'm going to pull out a negative 10x. So pull that out. Inside, you're going to have x squared minus 10x, then plus 9. Okay, don't forget you're pulling out a negative, so that's going to change this sign. Instead of being negative, it's positive. This is positive goes to negative, negative goes to positive. So let me set this equal to 0 here, and let me come down. So now let me factor the inside. So negative 10x times the quantity. Go ahead and put this here. Put this as 0, x here, and x here. 2 integers that give me a sum of negative 10, but a product of positive 9. Well, that's easy. I could do negative 9 and negative 1. And again, I'm just going to set each factor with a variable here equal to 0, and I'm going to solve those equations. So in this case, because you have an x out here, you want to set this negative 10x equal to 0. So that's something you need to consider. Then also you have x minus 9 equal to 0. Then you have x minus 1 is equal to 0. So this one, again, you divide both sides by negative 10, you get x is equal to 0. Add 9 to both sides here, you get x is equal to 9. Add 1 to both sides here, you get x is equal to 1. So x can't be 0, it can't be 9, and it can't be 1. So let's say x cannot be equal to, we had 0, we had 1, and we had 9. Okay, let's put this over here. From the numerator, I can factor a 5 out, and I would have x minus 9 like that. And then again, I can cancel common factors. So I can cancel, let me use a different color here so it shows up. I can cancel this with this common factor of x minus 9. Then also I can cancel a common factor of 5 between here and here. This is canceled completely, so I'm just going to put a 1. And then here, this is 10 divided by 5, which is 2. You got a negative out in front, so let's just say this is negative 2x. So let me actually erase this. Let me write this more cleanly. So this is going to be a 1 in the numerator. And then over, you're just going to have a negative 2x. So a negative 2x times this quantity x minus 1. So times this quantity x minus 1. Again, your restrictions always come from the original rational expression. So x is not equal to 0, 1, or 9. All right, let's look at problem number 8. Scroll down a little bit. We have our 4x cubed minus 38x squared minus 20x over 14x squared minus 146x plus 60. So again, the denominator, 14x squared minus 146x plus 60. Set that equal to 0. I know I can pull out a 2 here. So if I did that, I would have 7x squared minus 146 divided by 2 is 73. So 73x plus 30. Close that down, set that equal to 0. So this isn't something we factor a lot. We have some larger numbers. So if you're more comfortable, you can use the AC method. I still like using reverse FOIL, especially when this first guy here, this 7, the leading coefficient, is prime. So I can just put a 7x here and an x here, and then I can just go through the factors of 30. I know there's a lot of them, but I don't think it'll be that bad. You can't put a 30 here, and you put a 30 here, that's just not going to work. So 1 and 30, if you want to list these, is out. Then if you think about 2 and 15, 15 here is too big, and 15 here is too small. Get rid of that. You've got 3 and 10. 10 here and 3 here, I think that's what we want. So remember, because this is plus here, you're going to be adding. Forget about the fact that it's negative in the middle. Just working with absolute values. So if I do the outer, I'd have 70, and the inner would be 3. 70 plus 3 is 73. I need a negative 73x, so I just want to put a minus here and a minus here. So I get negative 70x plus negative 3x, which gives me that negative 73x. Okay, so now that we have this guy factored, let's go ahead and set each factor with a variable. So don't worry about this 2, equal to 0, and solve. So you'd have 7x minus 3 equals 0. You have x minus 10 equals 0. So here, just add 10 to both sides. You get x is equal to 10. Here, add 3 to both sides. That's going to cancel this. You'll have 7x is equal to 3. Divide both sides by 7. We get x is equal to 3/7. So x is not going to be able to be equal to 3/7 or 10. So x is not equal to 3/7 or 10. And let me make my fraction bar. So for the numerator, we have this 4x cubed minus 38x squared minus 20x. I know I can pull out a 2x there. That would give me 2x squared, then minus 19x, and then minus 10. Okay, so for this guy, let's go ahead and set this up. We have our 2x out in front, and then let me slide this down. So we're going to have 2x and x here. Let me actually make this longer. So put this here so it matches. So x here. Now I have a minus here, a negative 10 basically. So I can only work with, I'm just going to think about this in terms of pauses, but I need to subtract. I have 1 and 10. So if I put a 10 here and a 1 here, would that work? Well, the outer would be 20. The inner would be 1. And if you subtract, you would get 19. So it looks like that's what I'm looking for. So let me actually erase all of this. And I want to make sure that I end up with a negative 19x. So this needs to be negative and this needs to be positive. So I can cancel this common factor of x minus 10. And then I can cancel this common factor of 2. And what I'm going to be left with is x. Let me just erase this all together. X times the quantity 2x plus 1 over 7x minus 3. So over 7x minus 3. Again, my restrictions, x cannot be equal to 3/7 or 10. All right, let's look at problem number 9. Let's scroll down here. We have 10x cubed plus 70x squared minus 80x over 2x plus 16. So again, just take the 2x plus 16, set that equal to 0. I can factor this, probably easier to solve it that way. So 2 times the quantity x plus 8 is equal to 0. So obviously don't worry about the 2, you just need to set the x plus 8 equal to 0. And obviously there, x can't be negative 8. So x is not allowed to be equal to negative 8. So let me set that up. Okay, so we have the denominator factored. What about the numerator? Let me get this down here because this looks like it's a little bit complicated. Well, maybe not so much now that I look at it, because I can pull out a 10x, and inside we'd have x squared plus 7x and then minus 8. So that's actually really easy to factor. Let me put the 10x here, and then let me set up my parentheses. Bring that down. X goes here and here. So two integers that sum to 7 and give me a product of negative 8. Well, that's going to be positive 8 and negative 1. So positive 8 and negative 1. So again, you see that you have this common factor of x plus 8 that can be canceled. So let me just slide this down. You have 10x times the quantity x minus 1. So 10x times the quantity x minus 1. Let me get rid of this. We don't need this anymore. And then down here, everything's canceled except for the 2. And then, of course, we can still cancel because this 10 is divisible by this 2. 10 divided by 2 is 5. So you can really get rid of this altogether and put this as a 5x times the quantity x minus 1. And again, there's no denominator here, but you always want to carry your restriction over from the original rational expression. Okay, I can't tell you how many times people put just this. They don't leave anything because they don't see a denominator, but you have to carry this over. Otherwise, your teacher is going to mark points off. So make sure you put that x is not allowed to be equal to negative 8. All right, let's look at the final problem, number 10. We have 56x squared plus 120x plus 16 over 16x squared minus 24x minus 112. Let me slide down here a little bit. And again, I'm just going to take the 16x squared minus 24x minus 112. Set that equal to 0. What can I pull out here? I know I can pull out 2, but I can also pull out 4, right? Look at the last two of this. And I can also pull out an 8, actually. So I know 16 is divisible by 8. I know 24 is. 112, you would just check that on a calculator. And you get 14 if you divide that by 8. So I can pull out an 8 here. That's going to be helpful. So I'll have 2x squared minus, I'll have 3x, and then minus 14. Okay, set that equal to 0. Let me actually get rid of this. And let me slide this up here so we're not all over the place, and come down a little bit. So pretty easy to factor this. I'm going to have 2x here, and then I'm going to have x here. So let's see, I've got a negative 14 here. All right, so let's start with you have 1 and 14, or you have 2 and 7. For 14, you cannot put it here because you'd have a common factor of 2. You could put it here, and you could put a 1 here, but that is 28 here. 2 times 14 is 20. It's just too big, so that's never going to work. So you can immediately get rid of this and work on 2 and 7. So I cannot put a 2 here, but I could put it here, and I could put a 7 here. So the outer, 2 times 2 is 4, and then 7 times 1 is 7. 7 minus 4 is 3. So I need to make sure that this inner guy here is negative, and this guy on the outer is positive. So this would give me plus 4x for the outer, and minus 7x for the inner. That would combine to give me that negative 3x. Okay. So forget about the 8. You're just going to take the 2x minus 7, set that equal to 0, and then take the x plus 2 and set that equal to 0. So only when you have a variable in your factor do you need to worry about it. So let's come down here. We're going to add 7 to both sides. We'll say 2x is equal to 7. Divide both sides by 2. You get x is equal to 7 halves. Or if you want to write 3.5, that's up to you. I'm going to subtract 2 away from each side of the equation. This is x equals negative 2. All right, so x can't be negative 2 or 7 halves. Okay, so let me list the restriction. X cannot be negative 2 or positive 7 halves, or again, you could write 3.5. Now, for simplifying, let me scooch this down a little bit. And let me put my fraction bar here. The numerator, let me see, 56, 120, and 16. I'm thinking we can pull out a 4, but I think we can pull out an 8 from this as well. What is 120 divided by 8? That's going to be 15, so it looks like we can do that. And so if we pull out an 8, we would have 7x squared plus 15x and then plus 2. So can I factor this? Let me scroll down a little bit. I'll come back up just to get some room. So I would have 8 and then 7x here and then x here. Again, if you're factoring something you're struggling, if you don't know, you can always check stuff. Now, I don't see a 7x in the first position of each, so I'm going to guess that this is plus 2, right? X plus 2. So if I think about this guy right here, so I would want a 2 here, and that means I would want a 1 here, right? So does this work? The outer would be 14x, the inner would be plus x, yes. So without even thinking about it, I found my correct factorization, right? So that's how you can kind of cheat a little bit and look at, okay, what's in the denominator? A lot of times these things are going to cancel, okay? So let me get rid of this. And let me slide this up here. And let me come back into focus there. Okay, so we know 8 over 8 is 1, right? Cancel a common factor of 8, that's gone. Then I can cancel a common factor of x plus 2. So what I'm left with is 7x plus 1 over 2x minus 7. Let me get rid of this. And you can actually remove the parentheses. Don't need them in this case. And just put a fraction bar. And then I'll just say x is not equal to negative 2 and then 7 halves. All right, let's take a look at our practice test. So we're told to simplify here. And for the first problem, let's take a look at, we're going to have 18 over 11 times, we have 6 over 17x. What you want to do is first simplify each rational expression. So is there anything I can do to cancel? Then I want to cross cancel anything. And then once that's done, I'm just going to multiply the numerator times the numerator and put this over the denominator times the denominator. So just like working with fractions, no difference. So for this one, if I look at 18 and 11, nothing I can do. 6, forget about the x, 6 and 17, nothing I can do. And if I look across, 18 and 17, no. 6 and 11, no. So everything there basically is as simplified as I can get it. And so I'm just going to multiply across. So 18 times 6 would be 108. And then 11 times 17x, well, 11 times 17 is 187. And then x would come along for the ride. So that's our answer there, and we can't make it any simpler. We just have 108 over 187x. All right, let's look at problem number 2. So here we have 11 over 7x times 20 over 6. So for 20 and 6, I can certainly make that simpler. They're each even numbers, so they're divisible by 2. So let's write this as 11 over 7x times, I'm going to divide this by 2, I'm going to get 10. I'm going to divide this by 2, I'm going to get 3. So now 10 over 3, that's a simplified fraction. Now I'm going to look across. So 11 and 3, and then 7 and 10, nothing I can do. So now I'm just going to multiply across. 11 times 10 is going to be 11, put a 0 at the end, so 110. This is over. You're going to have 7x times 3. 7 times 3 is 21, and then x would come along for the ride. So we're going to end up with 110 over 21x. All right, let's look at problem number 3. Now we have a division problem. And so let's read the problem, and then I'll go through what we're doing here. So we have x squared plus 14x plus 49 over x plus 7. This is divided by, we have x plus 7 over x plus 2. So if you're dividing rational expressions, you have one additional step. You're going to convert this division into multiplication of the reciprocal. So just like we did with fractions. So really, I could write this problem as x squared plus 14x plus 49 over x plus 7 times, again, you're taking the reciprocal. So this comes down here, this goes up here. So you'd have x plus 2 up here, and you'd have x plus 7 down here. Okay, so from here, let me scooch down. I'll put equals. And you just want to factor everything and see what you can cancel. For a lot of these problems, you're going to cancel so many things, sometimes you don't even need to multiply. So up here, this is the only thing I really need to factor, and it's pretty easy to factor it. Let's go ahead and convert this. This would be x, and this would be x. And basically, if I want two integers whose sum is 14 and whose product is 49, well, that's going to be 7 and 7. So obviously, this is a perfect square trinomial. So you could write this as x plus 7 quantity squared. But for the purposes of this video and canceling, I'm just going to keep this expanded. So x plus 7 like this, and then times x plus 2 over here over x plus 7 like this. So now you're going to cancel any common factors that you can. So what do I have? I have an x plus 7 here that can cancel with this x plus 7 here. I have this x plus 7 here that can cancel with this x plus 7 here, again looking across. So you'll see that this rational expression is completely canceled. It's now just 1, and basically all I'm left with is just this x plus 2. I don't really need to multiply at this point. I can just say my answer, let me put this down here, my answer is just x plus 2. All right, let's look at problem number 4. Let's come down here. So we have 1 over x squared plus 12x plus 35 divided by x minus 6 over 2x cubed plus 10x squared. Okay, let me factor everything. I'm going to put 1 over. I'm going to put this as x here and x here. Two integers that sum to 12 and give me a product of 35. That would be 5 and 7. Let me put that there. I'm going to multiply by, and I'm just going to flip this. The x minus 6 is going to come down here, and then this is going to come up here. Can we factor this? Pull out a 2x squared. So inside, what are you going to have? You're going to have an x plus a 5. Okay, and again, I flipped this. This came into the numerator, this came into the denominator, and we changed this to multiplication. Okay, so I'm just multiplying by the reciprocal. All right, so from here, what can I cancel? So here I can't cancel anything, here I can't cancel anything. I can get rid of this x plus 5 with this x plus 5 here, so that's gone. I think that's pretty much all we can do. So now we just multiply. In the numerator, you're going to have 2x squared over, in the denominator, you'll have the quantity x plus 7 times the quantity x minus 6. All right, let's look at problem number 5. Let's come down here. We have 1 over 8x minus 48 times x squared minus 12x plus 36 over x minus 8. All right, so what can we do here? We have 1 over. From this guy, what could I pull out? Well, it looks like I could pull out an 8, and that would give me x minus 6 inside the parentheses. It's multiplication, so I don't need to worry about taking the reciprocal or anything. I'm just going to factor. So up here, let me put an x here and an x here. Two integers that sum to negative 12 and give me a product of positive 36. Well, again, you got another perfect square trinomial because this is going to be x minus 6 and x minus 6. So x minus 6 quantity squared. Let me put this over here. I have x minus 8 down here. What I want to do is cancel one of these with one of these. And I think that's pretty much all we can do because all you're going to have in the numerator is x minus 6. And the denominator would be 8 times the quantity x minus 8. So again, when you go through and multiply, make sure you put parentheses around things so that it's clear. You don't want to just multiply 8 by x and then have the minus 8 there. It's got to multiply by the whole quantity. So let's come down here. Let me put equals. So the numerator would be x minus 6. I don't need any parentheses there. It's not multiplying anything else. In the denominator, I want 8, and then I do want parentheses for this quantity x minus 8. Let's look at problem number 6. So we have 2x minus 8 over 10x squared plus 2x divided by 2x squared plus 4x minus 48 over 45x squared plus 9x. So let me take this guy. The first one I can factor out a 2. I'd have x minus 4 inside. From the second one, I could pull out a 2x, and that would give me 5x plus 1. So this is factored and this is factored. At this point, I could cancel a 2 with this guy and this guy and get rid of that. I'm going to put times. Again, I'm going to multiply by the reciprocal of this. So this is going to come up here. This is going to go down here. But I'm going to be factoring. So I'm going to take this 45x squared plus 9x. I'm going to factor it and put it in the numerator. So 45 and 9 have a common factor of 9. X squared and x, I could pull out an x. So inside this would be 5x and then plus 1. So you can already see that this is going to cancel. So you can just cancel this with this. That's gone. Then this guy's coming into the denominator. Looks like I could first pull out a 2, and I'd have x squared plus 2x minus 24. So then this would factor into what? X here and here. Two integers that sum to 2 and give me a product of negative 24. That's going to be positive 6 and a negative 4. Can I do anything with that? Yeah, it looks like I can. Let me erase this and scooch this up in here so it gets into the right position. I'm going to cancel this factor of x minus 4 with this factor of x minus 4. So this is a 1 up here. And basically, I'm going to cancel this x here with this x here. So this rational expression on the left is completely canceled. It's just really a big fat 1. So let me erase this and put a 1 here. And then all I really have left is 9 over this 2 times the quantity x plus 6. Let me come down here, and I'll put 9 over 2 times the quantity x plus 6. All right, let's look at problem 7. So what we have here is 5x minus 3 over 5x squared plus 32x minus 21. Then we're dividing by 35x cubed minus 5x squared over the 28x minus 4. All right, so division, let me just take this first guy, the 5x minus 3 over. I'll factor this. Let me go ahead and set this up. This guy right here is a prime number, so I'm just going to do reverse FOIL. Again, if you like the AC method, you can use that. It's no big deal. It's the same answer. So this guy right here is negative, right? So that means I'm going to be subtracting. If I put 21 and 1, I don't think that would work. 21 here is too big. 21 here is too small. Remember, you have to subtract. So the next thing I think about is 3 and 7. I could put a 7 here and a 3 here. Again, you're subtracting. 5 times 7 is 35. 3 times 1 is 3. 35 minus 3 is 32. Okay, so that's what I want. I want this to be plus so that this guy is plus 35x. And this got to be minus so that this is minus 3x. So those two guys would combine to give me this plus 32x in the middle. So this is what I'm looking for. Okay. Let me close that down. And so times over here, remember, we are replacing this division with multiplication by the reciprocal. So this 28x minus 4 comes into the numerator. I'm going to factor out the 4, and I'll be left with a 7x minus a 1. And then for this guy, the 35x cubed minus 5x squared, I could pull out a 5x squared. I would have 7x minus 1. So what can I cancel? 7x minus 1, 7x minus 1, that's gone. Then I have 5x minus 3 over 5x minus 3. If you want, you can wrap this in parentheses and put times 1 to make that more clear in terms of why you can cancel that. And then what I'm really left with, let me scroll down a little bit. For the numerator, it's just 4. For the denominator, I'm going to have this 5x squared times the quantity x plus 7. All right, let's look at problem number 8. Let's scroll down a little bit. We have our 7x squared plus 47x minus 14 over 14x squared minus 63x. This is divided by 42x cubed minus 12x squared over 14x squared minus 63x. Okay, so the first guy up here, let's see. I know I could put a 7x here and an x here. I know this is subtraction. So for 14, I really just have 1 and 14. So I can't put the 14 here, but I could put it here. But I think that's just too big. So that doesn't work. So we'd have to go to 2 and 7. If I put a 7 here and a 2 here, 7 times 7 is 49. 2 times 1 is 2. 49 minus 2 would be 47. So I want this to be positive and this to be negative. Right? My outer is 49x. My inner is minus 2x. So that would give me the 47x that I want. Okay, over here, we have 14x squared minus 63x. I could pull out a 7x. That would give me 2x, then minus 9. Okay, so times, again, I'm taking the reciprocal here. So this 14x squared minus 63x, this is the same thing as I got right here. So I can just copy my factorization. This is 7x times a quantity, 2x minus 9. And of course, this is going to end up canceling, right? This will cancel with this completely. The 7x over the 7x is 1. The quantity 2x minus 9 divided by the quantity 2x minus 9 is 1. So just canceling common factors. Then this guy's going to come down here. If I factor 42x cubed minus 12x squared, looks like I can pull out a 6x squared. That would be 7x and then minus 2. So we can see that we cancel this factor of 7x minus 2 with this factor of 7x minus 2. And really all I'm left with here is this x plus 7 over 6x squared. All right, let's look at problem number 9. So we have this 8x minus 36 over 2x squared plus 9x plus 9. This is multiplied by 6x plus 9 over 6x minus 27. Okay, so from the first guy over here, I can pull out a 4, and that's going to give me 2x minus 9 inside. From this guy down here, let's go ahead and factor this. I know this would be 2x and x. Everything is positive, so let me put a plus here and a plus here. So for 9, you've got 1 and 9, or you've got 3 and 3. Let me make this plus a little bit better. If I go 9 here, that's too big because we're adding, right? That would be 18. So I'd have to go 3 here and 3 here. The outer would be 6x. The inner would be 3x. 6x plus 3x is 9x, so that's what we want. Then times, for this guy, I could just pull out a 3. So that would be 2x plus 3 here. And we're going to cancel. I'm just going to go on for this one and we'll come back. So for this one, I can pull out a 3 as well. And that would give me 2x minus 9. Okay, so a lot of stuff will cancel. The 2x plus 3 here would cancel with the 2x plus 3 here. And then the 2x minus 9 here would cancel with the 2x minus 9 here. The 3 here would cancel with the 3 here. And anything left? I think that's it. So let's come down here. We'll have our 4 over x plus 3. All right, let's look at problem number 10, the last problem. So we have 14x cubed minus 42x squared over 6x minus 18 times we have the 9x plus 24 over 24x cubed plus 64x squared. All right, the first guy, let's see, I can pull out a 14 actually, because 42 divided by 14 is 3. So 14, and then I can pull out an x squared. So that is going to give me x minus 3. This is over 6x minus 18. I could pull out a 6, and I have x minus 3 inside. So you can already cancel. Let's just leave it till the end. We'll get to it in a minute. Over here, it looks like I could pull out a 3. That would give me 3x plus 8 inside the parentheses. And then down here, I can pull out a 4, also an 8. I think that's it. So 8 and then x squared. So that's going to give me what? 24 divided by 8 is 3. And then x cubed over x squared is x. And then plus this would be 8. And that's it. Close the parentheses. Okay. What can we cancel? Looks like a lot of stuff. So let me change colors here. I'll use an orange. So this 3x plus 8 will cancel with this 3x plus 8. So that's gone. Let's cancel this x squared with this x squared here. That's gone. Then let's cancel this x minus 3 with this x minus 3. So that's gone. So now I have 14, I have 6, I have 3, and I have 8. So 6 divided by 3 is 2. Then let me cancel this in a different color. 14 divided by 2 is 7. So all I really have left is 7 over 8. So let's put this over here and say this is 7 over 8 for our answer. All right, let's take a look at our practice test. We're told to find the LCD, which stands for least common denominator. And essentially for problem number 1, we're going to be looking at 19x over 2x minus 6, and then also 5 over x squared minus 3x. So the purpose of this lesson and practice test is to just get us ready for adding and subtracting rational expressions. When there's not a common denominator, just like with fractions, we're going to need to put each rational expression as an equivalent rational expression with the LCD as its denominator. So how do we find the LCD? The first thing you always want to do is factor everything and then see, can I cancel anything between the numerator and denominator? So can I simplify the rational expression? You want to do that first, because if you were to add two rational expressions or subtract them, you wouldn't do it with unsimplified rational expressions. So you want to make that as simple as you can. So for this one, let's start with 19x over, if I factored a 2 out, I'd have x minus 3 here. Can I cancel anything? No. Then for this one, I have 5 down in the denominator, pull out an x, I'd have x minus 3. Can I cancel anything? No. And at this point, I'm not multiplying, I'm not dividing. I just have two rational expressions here. So I'm only looking to simplify here and here and here and here. That's all I'm looking to do. Now let me scroll down a little bit. When we think about the LCD, once we've simplified, we're only thinking about the denominators. So the LCD is the least common multiple. I know everybody gets these confused, but the least common multiple of the denominators. So for that, you're going to list all your factors. And if there's a duplicate factor, you go with the largest number of repeats between any of the factorizations. So in other words, here I have 2 and I have x. I'm just going to put those in. So 2 and then x. Only occurs once here, only occurs once here. It's not duplicated. I don't need to worry about it. Here's where it gets tricky. You see that I have x minus 3 here and then also here. So x minus 3, that quantity is going to go in when I build my LCD. But it's only going to go in once, because if it's a duplicate, or you could say a repeat between this factorization and this factorization, well, I go in with the highest number of repeats. This is to the first power, this is to the first power, so I only need to put one of those in when I build my LCD. Then once you're done, you just multiply everything together. In this case, it's just 2x times the quantity x minus 3. Okay, let's look at problem number 2. So here we have 5x squared minus 1. Can I factor that? No. So I would just leave that. And then down here, I'm going to have x squared plus 2x minus 3. Can I factor that? Let's give it a shot. So let's go ahead and set this up. Put an x here and an x here. Give me two integers whose sum is 2 and whose product is negative 3. So 3 is 3 and 1, so I'd have to work that in such a way. Let me go ahead and say that I would want a positive 3 and a negative 1. So that would work, right? Negative 1 plus 3 is positive 2, and negative 1 times 3 is negative 3. Okay. Can anything cancel between numerator and denominator? No. Let me make this fraction bar a little bit bigger. Here, 2x plus 3, I can't do anything with that. Just rewrite it. And then x squared plus 3x, I can pull out an x. Inside I'd have x plus 3. Again, I'm not looking to cancel anything crossways or anything like that. We're not multiplying. Just look to see if you can cancel anything. I know a lot of students are going to look and say, oh, I can cancel x plus 3 here and here. That doesn't work that way, right? Remember, we cancel common factors. You have a factor up here. You can think about this as 2x plus 3 times 1 if you want. Down here, it's x plus 3, so you can't cancel down there. Okay, so let's get rid of this. Let's just think about the denominators now. So when I build my LCD, again, just go with each factor. So x minus 1 is going to go in there. And then x plus 3 is going to go in there. And then x is going to go in there. And I'll reorder this in a second. Now, how many times does x plus 3 go in there? Again, if you have a duplicated factor, so it's here and here, you go with the largest number of repeats. So here, it's raised to the first power, and here it's raised to the first power. So that's how that's going to go in, just once. And I'll put the x out in front just to make that a little bit more standard. So the LCD is x times the quantity x minus 1 times the quantity x plus 3. Okay, let's look at problem number 3. So we have 3x squared minus 5x plus 7 over x squared minus x minus 2. So can I factor this? I don't think we can. Let me try. So with 3x and an x, so 7 is a prime number, so it's only 1 times 7. So if I put a 7 here, that's 21, that's too big. If I put a 7 here and a 1 here, this would be 3 and 7. 7 minus 3, I'm just working with absolute values, is 4. That doesn't work. So this is prime. So we'd have 3x squared, then minus 5x plus 7. Can't do anything with that. This right here is x here and x here. So this is a negative 1. So give me two integers whose sum is negative 1 and whose product is negative 2. Well, 2 is 1 times 2 only. So let's go ahead and put a plus here and a minus here. I know the signs are different. And I know if this guy is negative, I want the larger in terms of absolute value to be negative, so negative 2 and positive 1. And of course that works. 1 minus 2, or 1 plus negative 2, is negative 1. 1 times negative 2 is negative 2. Okay, so this is as good as we can get it. We can't simplify. Over here, probably need to write this off to the side. You have x cubed plus 5x squared minus 4x minus 20. Now, if you see a 4-term polynomial, what are you supposed to do? You're supposed to try to factor this using grouping. Okay, that's always the case. So we start with that. Can I pull something out from the first group? I can pull out an x squared. I would have x plus 5. From the second group, let's pull out a negative because these are both positive, and I'm going to pull out a negative 4. So this would give me x plus 5 inside. So I have a common binomial factor, this x plus 5 here. So I'll have this x plus 5 quantity times the quantity x squared minus 4. Now you may notice that we're not done because x squared minus 4 is the difference of squares. So let me erase all of this. And actually, I can probably slide this up here at this point. And let's scooch back up so we're back in frame of the problem. So this x squared minus 4 would further factor into x plus 2. So x plus 2 times x minus 2. So this quantity times this quantity. Let me make the parentheses, or the parenthesis, since it's singular in this case, a little bit better. And close this down. Okay, so down here, I have what? I have x here and x here. Two integers whose sum is 7 and whose product is 10. That's easy. That's 5 and 2. Now, what you'll notice here, again, you want to cancel this with this and this with this. So you have a common factor of x plus 5 and a common factor of x plus 2. The denominator is canceled. So if you were adding these two rational expressions, you'd want to keep that in mind because you want to make sure you're adding things that are simplified or subtracting or whatever you're doing, because otherwise you're going to do a bunch of extra work, okay? So I want to cancel that out and actually just say that this rational expression is really just x minus 2 over 1. So this is x minus 2 over 1. And what is the LCD if this guy's 1? Well, the least common denominator is just going to be this. If I was adding these guys, I would need to multiply this rational expression by this over this. Okay, that's how I would do that. So I would have a common denominator. So let's go ahead and put this LCD here as the quantity x plus 1 times the quantity x minus 2. So that's going to be my LCD. All right, let's look at problem number 4. So we have 4x over 3x squared. So immediately I can cancel an x. So I could say this is 4 over 3x. This guy, we have 2x minus 1 over. I could pull out a 6x. That would give me x minus 7. And then this guy up here, let's see, we have 3x. Let me make that better. So we have 3x here, and we have x here. So for 9, it's either 9 times 1 or 3 times 3. Now this is a plus here, so the signs would both have to be negative because of this negative here. So if I did a 9 here and a 1 here, that does not work. Now, I can't put the 9 here because I'd have a common factor of 3, and there's no common factor of 3 here, and I can't do 3 and 3 because of the same reason. So this is actually prime. You won't be able to factor this here, so we're going to put 3x squared minus 10x plus 9 over. I'm going to pull out an x squared here, and I'll have my 2x plus 1 here. Okay. Anything else I can do? No. So let's go ahead and build the LCD. So for the LCD, what do we have? Well, number-wise, we have a 3, but then we have a 6. Now, think back to when you work with these LCDs, or when you work with finding the LCM and you have numbers, you're going to factor these numbers completely. So 6 is really 3 times 2. So if I had 3, and I had 3 times 2, well, again, this 3 appears here and here. It's duplicated, so I only want 1 in when I build this, and then I also want times 2, so really I want 6 there. Okay, so I'm not going to put, the common mistake is 6 times 3 and to put 18 in there. You don't want to do that. Okay, you only want 6. Then you have x, and then you have x here. So you only want one of those, but then you have x squared here, so you want 2 of those. So again, when you look at this, you have an x, you have an x, and you have an x squared. So it's a repeated factor. You can think about it as a duplicate factor. You go with the largest number of repeats or the highest exponential power. So this is to the first power, this is to the first power, and this is squared, so you put x squared in there. Now, when you look at the rest of this, you have x minus 7, and then you have 2x plus 1. So that just goes in there. So this guy, I know it's a little bit tricky. You have 6x squared times the quantity x minus 7 times the quantity 2x plus 1. Okay, let's look at problem number 5. So we have, up in the numerator, 4x squared minus 1. That's the difference of squares. So this would actually be 2x plus 1. This quantity times 2x minus 1, that quantity. So that factors. Down here, this is the difference of squares as well. This is the quantity x plus 3 times the quantity x minus 3. Then up here, I have 2x minus 9. Nothing I can do with that. Then I have this x here and x here. So give me two integers whose sum is going to be 2 and whose product is negative 3. Well, I know the signs are different, so plus and minus. And I know 3 is only 3 times 1. And this guy's positive, so I want to put a 3 here and a 1 here. Does that work? 3 minus 1 is 2. 3 times negative 1 is negative 3. So that's good. All right, nothing I can do to simplify. This one I probably need to do off to the side. Let me scroll over a little bit, actually. I think we can fit it over this way, and we'll come back over. So we have 5x squared minus 7x plus 1. Let me try to factor that real quick. I don't think you can. This is 5x and this is x. 1 is only 1 times 1. If I put a 1 here and a 1 here, that obviously does not work. So this guy is going to be prime. You can just leave that there. Then for this guy here, you could factor out an x, and then you would have x squared minus 4x plus 3. So this would further factor. You have an x here and an x here. 3 is going to come from 1 times 3 only. This is negative here, so you want minus 3 and minus 1. Okay, so that does work out. Let me get rid of this. Now let me throw this up here. And not everything's going to fit on the screen, so let me actually grab this and move it over. And we'll slide back over here. Slide back over here like this. And maybe I'll put my comma like this. Let's scroll down. So nothing cancels anywhere, so you don't have to worry about that. We're just looking at all the different factors that we have. So if I look at this, I have x plus 3, I have x plus 3, and that's it. So that's going to go in. Let me build the LCD. So let's put our x plus 3. So that's in there. Then next, let me erase this and this. You're going to have x minus 3. Don't have it there, but I do have it here. So again, it only occurs once here and here, so you only have to put 1 in. So let me change colors and put x minus 3 in there. Okay, so that's there. Let me check these off as I'm using them so I don't forget. And let me check that off. Okay, so next, it looks like I have this x minus 1. So let me erase this. And let me highlight this and this. So again, 1 and 1, so I only have to put 1 in there. And I should probably change colors here. So let me change to black. So I'll put x minus 1 in there. And so let me check off this and this. So we have everything except for this x here. I'm going to put that out in front. So the LCD here, and let me check that off, would be x times the quantity x plus 3 times the quantity x minus 3 times the quantity x minus 1. All right, let's take a look at our practice test. We want to simplify each. And for the first problem, we're going to be looking at 6x over x plus 1. We're subtracting away 5 over 5x cubed. So the idea here, before we even get started, you would notice that you have a common factor of 5 between the numerator and denominator here. So I'm just going to go ahead and cancel that to make my job a little bit easier. And I'm going to put a 1 up there. You don't need a 1 down there. It's unnecessary. Let me just rewrite this as 6x over. I'm going to put x plus 1 here, and then minus. You're going to go 1 over x cubed. Now, the next thing is if you're adding or subtracting fractions or rational expressions, you have to have a common denominator. So what is the LCD here? What is the least common denominator? We talked about that in the last lesson. Essentially, in this case, we have these guys, x plus 1, I can't really do anything with that. X cubed, I can't do anything with that. So here it's just going to be the product of the two denominators because they don't have anything in common. So it's just going to be x cubed times the quantity x plus 1. Okay, so that's my LCD. Let me slide that down so I have enough room to work. Let me put equals here. Now, how do I go about solving this problem? Well, I need to rewrite each rational expression as an equivalent rational expression where this LCD is its denominator. So in other words, I have 6x over, I'm going to wrap this in parentheses, so x plus 1, because we're going to be multiplying. I'm going to multiply this denominator by what I need to make it into the LCD. Well, I have the x plus 1, I just need the x cubed. So I can't just put the x cubed here. Again, to make it legal, I've got to do it to the numerator and denominator. Remember, this is just a complex form of 1. Multiplying by 1 leaves things unchanged. So then I'm going to subtract away, same process over here, 1 over x cubed, times, what am I missing? I'm missing the x plus 1. So I can go x plus 1 here over x plus 1 here. Okay, so let me get rid of this right here. Don't need that anymore. And now we're just going to go through, I'm just going to scroll down a little bit. We're going to go through and just simplify. So 6x times x cubed, the 6 would stay the same. X times x cubed is x to the 4th power. And then this is a little bit tricky. If you have subtraction involved, go ahead and put minus, put a bracket there. Okay, I'm going to close that down in a minute. And then whatever this is, I'm just going to put it in here. 1 times this would just be itself. So this would just be x plus 1, and then close that down. The reason I'm using brackets, or you could use parentheses if you want, basically I want to remind myself that I'm subtracting this whole thing away. The common mistake is just to do this, right? Minus x and then plus 1. That's not what's going on. You need to subtract everything away. So to remind myself to change the sign of each term inside of there, I'm going to put the minus out in front of, again, brackets or parentheses. Down here in the denominator, I can just write the LCD, right? So I have a common denominator now. So I can just say this is x cubed times the quantity x plus 1, and that's done. And now I just need to do some simplifying. So let's go ahead and take this 6x to the 4th power. I'm going to basically change the sign of each term inside the brackets here. So minus x and then minus 1. And then this is over x cubed times the quantity x plus 1. Now, whenever we think about a fraction or a rational expression, we always want to report an answer in the simplified form, right? So we want to factor the numerator and denominator and cancel any common factors. At this point in the course, we haven't talked about how to factor something like 6x to the fourth power minus x minus 1. So you might get stuck at this point and say, well, I don't know if I can simplify this or not. But actually, if you use a little bit of the knowledge we learned when dividing polynomials, you'll basically be good to go. If this guy can be simplified, it means that basically you would be able to factor out an x cubed, or you'd be able to factor out an x plus 1. We know that x cubed is not going to be able to be factored out here because this has an x to the fourth power. This is only x to the first power. So I don't have enough, and I don't even have an x here. So this is out of the question. The x plus 1 here, this is something we could check with synthetic division, right? So we could come over here and say, okay, well, if this guy divided by this guy gives me a quotient and then no remainder, well, then I know I could rewrite it, okay, using that quotient times the divisor. So how would I do this with the synthetic division really quickly? Well, remember, you need this to be in standard form, and you need to not be missing any powers on your variables. Here we're missing x cubed and x squared, so I could write 6 as the coefficient for x to the fourth power, 0 as the coefficient for x cubed, 0 as the coefficient for x squared, a negative 1 for the coefficient for x to the first power, and then a negative 1 for my constant, okay? So let me put this like this. And then what goes over here? Remember, this guy right here has to be 1x to the power of 1 and then minus k. So this can be rewritten as x minus a negative 1, like this, to match up the format that we need, and we want to grab that negative 1. Okay, so let me put this out here, and let me drop this down here, and just go through and see if you get a remainder. If you do, then this guy is basically good to go. It's simplified. If you don't, meaning your remainder is 0, then you have some additional work to do. So negative 1 times 6 is negative 6. Then 0 plus negative 6 is negative 6. Negative 1 times negative 6 is positive 6. 0 plus 6 is 6. Negative 1 times positive 6 is going to be negative 6. Negative 1 plus negative 6 is negative 7. Lastly, negative 1 times negative 7 is 7. Negative 1 plus 7 is going to be positive 6. So this is your remainder. It's obviously not 0. So this guy is going to be simplified, right? So we have 6x to the fourth power minus x minus 1 over your x cubed times the quantity x plus 1. All right, let's look at problem number 2. So we have 5 over 2x minus 7 plus 6 over 3x minus 5. So for this one, let's go a little bit quicker. For the LCD, we know in this case, 2x minus 7 can't factor that. 3x minus 5 can't factor that. Nothing's in common. So it's going to be the product of the two denominators. Now, instead of doing this, and let me write this out the long way so no one gets confused. So 5 over 2x minus 7. Let me wrap that in parentheses. To get to the LCD as my denominator, I would need to multiply by this other denominator, 3x minus 5, top and bottom. So we know this setup at this point. Let me put plus. We'll have 6 over this 3x minus 5 times, I'm going to multiply by top and bottom the other denominator. So 2x minus 7 over 2x minus 7. Now, do we need to do this each time? No. Because all I'm going to end up doing in the end, my denominator is going to be the LCD. So whatever that is, that's what you're going to write. And then this guy right here needs to multiply by whatever this denominator needs to be the LCD. In this case, it's going to be this other denominator. Then this guy right here, similarly, is going to multiply by whatever this denominator needs to be the LCD. Okay, in this case, it's this denominator here. So to shortcut this, let me erase this real quick. And I'm just going to do this for the rest of the practice test. I'm going to take this 5, and I'm going to multiply by this other denominator, this 3x minus 5. Then plus, I'm going to take this 6, I'm going to multiply by the other denominator, so this 2x minus 7, okay? Then this is going to be over the LCD, which is the quantity 2x minus 7, times the quantity 3x minus 5. Now, if this is confusing to you or you start making mistakes when you're doing it, you can always take the extra step of doing what we did the first time, okay? So let's come down here to put equals, and we're just going to simplify. So 5 times 3x is going to be 15x, and then minus 5 times 5 is 25. And then plus 6 times 2x is 12x. And then minus 6 times 7 is 42. We'll put this over this common denominator of 2x minus 7 times this 3x minus 5. So these two quantities. And really all we have to do is simplify in the numerator. 15x plus 12x is going to be 27x. And then basically you have negative 25 minus 42. That's minus 67. And this is over. You have your 2x minus 7, this quantity, times the quantity 3x minus 5. you're not going to be able to simplify this because the 27x minus 67, you can't do anything there. 27 is 3 cubed, and 67 is a prime number. So this is our simplified answer. All right, let's look at problem number 3. So we have 6 over x squared minus 3x minus 10, and then minus 6 over 7x squared. So let me slide down here. It doesn't look like I can simplify anything to start. I could pull a 6 out, but let me wait to do that. Let me go ahead and factor this first so we can get things started. This is an x here and an x here. I need two integers whose sum is negative 3 and whose product is negative 10. So let's go ahead and put negative 5 and positive 2. Now between these denominators, there's nothing in common. So my LCD is just going to be the product of the denominators. So the 7x squared times the quantity x plus 2 times the quantity x minus 5. Now I don't need to write this each time, but I'm just making that crystal clear. Now, let me actually get rid of this. I'm going to put equals. Now, what did we do in the last time to make this faster? We took this guy right here and multiplied by what it needed. So in this case, this is the 7x squared. I'm going to go ahead and do that. I'm going to end up factoring that 6 out. But just to make this clear what I'm doing, I'm just going to multiply it like this. Then minus, I'm going to go ahead and put this 6 here times this guy here. So this quantity x squared minus 3x minus 10. And then let me put this over this LCD here. So let me just erase this writing and just slide this up here. Okay. Now, as I was talking about, you could pull the 6 out. Okay. You don't really need that there because it's common to this and this. So you might as well save yourself the trouble because you go through and multiply it and then you'd have to just pull it out. So I'm just going to go ahead and say that 6 is going to be out in front. You would have 7x squared, then minus this x squared minus 3x minus 10. Now, I don't need brackets here, and I didn't use brackets there because you have a minus in front of these parentheses here, okay? So I know that to drop these parentheses, and I'm talking about these inner parentheses here, I need to change the sign of each term inside. So I don't use brackets in this particular case. This is over your 7x squared times the quantity x plus 2 times the quantity x minus 5. Okay, let me slide down a little bit, put equals, and we'll say 6 is out in front. The 7x squared would be there. Then I'm going to change the sign of everything here. So this is minus x squared. This is plus 3x. And this is plus 10. And let me close that down. So before we go any further, 7x squared minus x squared would just be 6x squared. So let's go ahead and write 6x squared here and just tighten this down like this. That way we don't have to worry about it. And I messed that up. So let me put the 6x squared and then plus 3x and then plus 10 like this. And let me put this over. We have 7x squared times the quantity x plus 2 times the quantity x minus 5. Now, at this point, you would check to see if 6x squared plus 3x plus 10 can be factored. And in the interest of time, because this video is going to be pretty long, I'm just going to tell you that it is prime. So we're just going to stop here and say this is our simplified answer. All right, let's look at problem number 4. So we have 5x over 8x minus 7 plus we have 5 over 2x minus 6. So you do have a 5 that's in common. So again, you could pull that out now if you want. I think it's probably better just to wait a little while. We will pull it out. Let me put equals here. What is the LCD? Again, it's going to be the product of the two denominators. There's nothing in common. This actually would factor to 2 times the quantity x minus 3. Again, you could write LCD out, but I think we know how to do it at this point. I'm just going to put 8x minus 7. I'm going to stick this 2 out in front here and then put my x minus 3 here. So just multiplying the two denominators to get my LCD. Okay. So for this guy right here, this 5x, it needs to multiply by this guy right here. Okay. This needs to multiply by this to get to the LCD. So I'm going to put 5x times this quantity 2x minus 6. And then I'm going to put plus, I have this 5 here that's going to multiply by this. So 5 times this quantity 8x minus 7. Now, as I mentioned, you want to pull this 5 out to save yourself some work because otherwise you're going to end up having to factor it back out, right? You're going to multiply and then have to factor it. I mean, you could do that, but it's just extra work, so I don't see the point. So let's go ahead and put equals and come down here. I'm going to pull that 5 out in front. And so inside, x times 2x is going to be 2x squared. Then minus x times 6 is 6x. Then plus, I already pulled the 5 out, so don't worry about that. We're going to have basically just 8x minus 7, because if you pull this out, you really think about it being a 1, and 1 times anything is itself. So go ahead and close this down. We could simplify it before we move on. Negative 6x plus 8x is going to be positive 2x. So you can put plus 2x there like that. And of course, let me slide this down, see if I can get it even. Yeah, that looks all right. Let me see if I can make that better. So minus 7 like this. And then this will be over. You have your 2 times the quantity 8x minus 7 times the quantity x minus 3. So again, this polynomial here, this 2x squared plus 2x minus 7, you can pause the video and check on your own if you can factor it, but you're going to find that it is prime, right? So this is our simplified answer. All right, let's look at problem number 5. So what we have here is 3x over x minus 6 plus 6x over x minus 5. So before you even start, notice that you have a 3x that could be pulled out. I think we'll wait to pull it out just for a moment. So we know the LCD here, this is x minus 6, this is x minus 5. It's just the product of the denominators. So I would take 3x and multiply it by the other denominator. That's what I would need, so x minus 5. Let me clearly make that better. And then plus, I'm going to write 6x as 3x times 2 because I'm going to end up pulling the 3x out. And then this is going to be multiplied by the other denominator, which is x minus 6. That's what I would need there. So let me slide this down a little bit. And then we're just going to write this over our LCD, which is the quantity x minus 6 times the quantity x minus 5. Now again, I told you I'm going to be pulling out this 3x. Again, if you make the mistake of distributing this in, you're going to have to pull it back out, and it doesn't really make sense to me. So just save yourself the work and do it now. So if I pull out the 3x, let me put that here. Inside the parentheses, first you'd have this x minus 5. So x minus 5. Really, there's nothing there to do anything with, so you don't need parentheses around that. Then plus, if you pull this out, you would have 2 times this quantity here. You can go ahead and multiply it now. 2 times x is going to be 2x. And then minus 2 times 6 is going to be 12. Go ahead and close that down. I know that x plus 2x would be 3x. So let me go ahead and write this as 3x here. And then I also know that negative 5 plus negative 12 is negative 17. So let me write 3x minus 17 like this and close that down. Let me put this over our denominator, which is going to be x minus 6, this quantity, times the quantity x minus 5. So this would be my simplified answer. There's nothing else I can really do. Let's look at problem number 6. So we have 3x plus 1 over x minus 6 plus 8 over 8x plus 32. So this, you should be able to eyeball and see that you can pull out an 8 there, and then you can cancel between numerator and denominator. So what you'd have here is 3x plus 1 over x minus 6, then plus, this is going to be a 1 up here, over this x minus 4. Again, you don't have to do this, but it just saves you work in the end. So let's come down here. Again, we have a situation where the LCD is just the product of the two denominators. So I'm going to multiply this numerator here, this 3x plus 1, by this denominator here, this x minus 4. Make sure to wrap this in parentheses because you're multiplying these two quantities. Let me go plus. I'm going to take this 1 here and multiply it by this denominator. So just x minus 6 because 1 times anything is just itself. Then put this over the LCD, which is x minus 6, this quantity, times the quantity x minus 4. Okay, let's come down here. 3x times x is 3x squared. Then we would get 3x times negative 4. That would be minus 12x. And then 1 times x is plus x. You can simplify that now. That would be minus 11x. Let's go ahead and do that. So minus 11x. And then 1 times negative 4 is minus 4. So then you have plus x and minus 6. So basically x plus negative 11x would be negative 10x. And then negative 4 plus negative 6 would be negative 10. So 3x squared minus 10x minus 10. You're not going to be able to factor that. Again, you can pause the video and try it if you want, but this guy is prime. So this is over x minus 6, this quantity, times the quantity x minus 4. Again, nothing else I can do, so this is my answer. Okay, let's look at problem number 7. So we have 7x over x plus 5, plus we have 6 over x plus 9. So let me slide down here a little bit and see what we're working with. So again, it's just going to be the product of the two denominators for the LCD. Can't really pull anything out, can't really simplify. So let's just take 7x and multiply by the quantity x plus 9. So again, this guy needs to multiply by this guy. Then plus, I'm going to take this 6. And what do I need? I need to multiply by this guy, so the quantity x plus 5. Let me move this down a little bit. Put this over. The quantity here, x plus 5, times the quantity here, x plus 9. Okay, so let's see what this is going to be equal to. 7x times x is 7x squared. Then plus 7x times 9 is going to be 63x. Then plus 6 times x is 6x. And plus 6 times 5 is 30. Let me simplify this now. 63x plus 6x is going to be 69x. So put that there like that. Get rid of this. Put plus 30 there. I'm just going to tell you again in advance that that's not factorable. This is going to be prime. So this would be over x plus 5, this quantity, times the quantity x plus 9. All right, let's look at problem number 8. So we have this 12x over x minus 12. We're subtracting away 11 over 11x plus 11. So with this guy, you can simplify. You could say this is 11 over Factor out an 11 from the denominator. This would be x plus 1 inside. This would cancel and you'd have 1 over x plus 1. So let's put equals. We'll put 12x over x minus 12, then minus 1 over x plus 1. So let's go 1 over x plus 1. So again, a very easy setup at this point. We know that the LCD would just be the product of the two denominators. So I could multiply 12x by this other denominator. So 12x times, wrap it in parentheses, the quantity x plus 1. Then minus, let me put some brackets here so I don't make a silly sign mistake. This 1 is going to multiply by the other denominator, so x minus 12. We put that there, put this over here, and then we have the product of the two denominators for the LCD. So x minus 12, that quantity times the quantity x plus 1. Okay, let me scroll down here a little bit, put equals. 12x times x is 12x squared. And then I'm going to go plus 12x times 1 is 12x. I'm going to drop the brackets and just change the sign of everything. So this would end up being minus x and then plus 12 like this. So 12x minus x would give me 11x. So let me put 11x here and then plus 12 there. Put that like that. And then this is over. The quantity x minus 12 times the quantity x plus 1. So nothing I can do to factor this in the numerator. Again, you can always pause the video and check. But this guy is going to be prime. So this is our simplified answer. All right, let's look at problem number 9 now. And this one, 9 and 10 are going to be a little bit tricky. So I gave you a bunch of ones that are pretty easy overall, and then the last two are kind of challenging. So let me put equals here. First off, before I do anything, I'm just going to factor everything just to see if anything would simplify. I haven't worked this problem yet. I know it does take a little bit of time, but let me go ahead and just factor this first to see what we're looking at. This would be x and this would be x. I need two integers whose sum is negative 14 and whose product is 33. So that is going to be negative 11 and also negative 3, right? So negative 11 plus negative 3 is negative 14. Negative 11 times negative 3 is positive 33. Okay. Then over this guy right here, I'm going to put an x here and an x here. And then essentially I need what? I need two integers whose sum is negative 6 and whose product is negative 55. So that's going to be negative 11 and a positive 5. So before I do anything, again, I can cancel stuff. You don't have to if you don't want to, but it just makes things so much easier. If you work with a simplified rational expression, you have a common factor of x minus 11 that you can get rid of. So now I have x minus 3 over x plus 5. So that's the first step for me. So then minus. Over here I have this 5. And then from the denominator, it looks like I can factor out a 3x. And then inside I'm going to have what? X plus 5. So let me come down here a little bit. And let's think about our LCD. This is canceled. Let me actually rewrite this. So x minus 3 over x plus 5 like this. And then minus, you have 5 over 3x times the quantity x plus 5. So the LCD is what? It's x plus 5. They have that in common. You just need the 3x. So this guy right here already has the LCD as its denominator. So you don't need to make any changes to that one, okay? So let me put equals here. And I'm only going to work with this one. I'm going to say this x minus 3, and let me just show this the long way so nobody gets confused, over x plus 5, and then times, what do I need to make this denominator into the LCD? I need the 3x. So 3x over 3x, and then minus, you have the 5 over the 3x times the quantity x plus 5. Let me actually wrap these to make them crystal clear what we're doing, like that. Okay, so now I have my LCD, and all I really need to do is say 3x times x is 3x squared. Then minus 3x times 3 would be 9x. And then basically I'm just subtracting away this 5 here. I don't need to use brackets or anything. It's just one guy. So I'm just subtracting away the 5. And this is over my LCD, which is 3x times the quantity x plus 5. So again, you could pause the video and see if you can factor that. I'm just going to tell you in advance this is going to be prime. So this is our simplified answer. Let me make that 5 a little bit better. We're just going to have the 3x squared minus 9x minus 5 over this 3x times the quantity x plus 5. All right, let's look at problem number 10. So we have 5x plus 10 over 8x to the 4th power plus 20x cubed plus 8x squared. Then we are adding this to, we're going to have x squared plus 3x over 8x to the 5th power plus 20x to the 4th power minus 12x cubed. So in this case, it will really be to your advantage to simplify everything first before you start adding. If you don't want to do that, you can go about it that way, but it's just going to take you a lot of extra time. So what I'm going to do is just factor everything first. So this, let me copy this 5x plus 10 over, let's put the 8x to the fourth power plus 20x cubed plus 8x squared. Let me grab this real quick, and let's go ahead and paste this in here. And let's see if we can simplify this. I know from the numerator, I could factor out a 5. So that would leave me with an x plus 2 inside. From the denominator, it looks a little bit more tricky. I know I could pull out an x squared variable-wise. And then number-wise, it looks like I can pull out a 4. Right? So I can pull out a 4x squared. So 8 divided by 4 is obviously 2. X to the fourth power over x squared is x squared. Then plus 20 over 4 is 5. X cubed over x squared is x. And then plus 8 over 4 is 2. X squared over x squared is 1. Now again, you always want to see if you can further factor this. Let me write 4x squared. And then let me see if I can set this up as the product of two binomials. So 2x and x. So 2 is only 1 times 2. The 2 can't go here, but it could go here. And 1 could go here. Does that work? Yeah, 4x plus x would be 5x. So this is what I'm looking for here. Now, when we look at this guy, can anything cancel? In other words, do we have any common factors between the numerator and denominator? Yeah, have a common factor of x plus 2. So let's get rid of that. Let's remove this from here. And let's write this guy as the simplified version, which is just a 5 over. You're going to have this 4x squared times the quantity 2x plus 1. Okay, let's get rid of this. It looks a lot easier to work with. Let's go back up. And let's factor this one right here, and then I'll go back down and we'll do the problem there. From the numerator, I can pull out an x. I'm going to have an x plus 3 inside. From the denominator, I know variable-wise I can pull out an x cubed, and obviously I can cancel, but I'll do that in a moment. Number-wise, it looks like I can pull out a 4 again. And then inside of here, I'm going to have 2x squared, and then plus 5x, and then minus, this will be 3. So can I further factor this? Well, let's think about this. We have, let me put this here. So 2x and x. Let me put this 4x cubed out here. Let's see. 3 is only 1 times 3. So if I put a 3 here and a 1 here, that would be 6 minus 1, which would be 5. So put a plus here and a minus here. Yeah, that will work. So let's go ahead and slide this up here. And let's see what we can cancel. So we know that this x here, let me change color so this is clear. This x here would cancel with one of these. I could put this as a 2. And then this x plus 3 would cancel with this x plus 3. So this is completely canceled. It's just a 1. So we could write 1 over this 4x squared times the quantity 2x minus 1. So let me grab this real quick. And let's come back down here and paste this in. Remember, we are adding these two. So now my LCD will not just be the product of the two denominators because they have something in common. Okay, so that trick where we just said, okay, well, this guy times this guy, that's not going to work here. So you really have to pay close attention to what you're doing. Let me actually write out what the LCD would be. So you have this 4x squared that's common to both. So you only have to list that once. Okay, then you would want to put in the 2x plus 1 that only occurs once here. And then you'd want to put in the 2x minus 1 that only occurs once here. Okay, now you could actually shortcut this thing, but you just need to remember what you're multiplying by. The 5 is only going to multiply by this 2x minus 1 because that's what the denominator is missing, okay? So you can do 5 times this quantity 2x minus 1, then plus this guy right here is missing what from the denominator? It's missing the 2x plus 1. So basically 1 times the 2x plus 1 like this. And again, you don't need the 1 there, but just for completeness. And the LCD here is going to be the 4x squared times the quantity 2x plus 1 times the quantity 2x minus 1. So you can get rid of this now. Okay, so this is pretty easy now that we did it this way. If you didn't simplify that, it would be a very, very long process to get the same answer, but you could still do it. So we'd have 5 times 2x, that's 10x, and then minus 5 times 1 is 5, and then plus 1 times anything is itself, so it's 2x plus 1. Let's go ahead and simplify this. Would be 12x if I added 10x and 2x. And then negative 5 plus 1 is negative 4. So 12x minus 4 over the 4x squared times the quantity 2x plus 1 times the quantity 2x minus 1. Now, can I do anything else? In other words, can I simplify this any further? Well, yeah, actually I can. I can pull out a common factor of 4. So I can say this is 4 times the quantity 3x minus 1, like this. And this will be over, let's have our 4x squared times the quantity 2x plus 1 times the quantity 2x minus 1. Close that down. And lastly, we see that this 4 would cancel with this 4. And so my simplified answer is 3x minus 1. Don't need parentheses. It's not multiplying anything. Over, you have this x squared out in front times the quantity 2x plus 1 times the quantity 2x minus 1. All right, let's take a look at our practice test. So we're told here to simplify each. Let's come down to the first question. And so let's read this guy. We have x plus 4 over. We have x plus 4 over 4, and then minus x plus 4 over 16. All right, so if you want to simplify a complex rational expression, you have a lot of different strategies to do this. I'm going to use the LCD method. And basically, I'm going to start by just writing, let's put equals here. I'm going to take this x plus 4, and I'm going to write it as having a denominator of 1. Remember, you can divide by 1, leaves it unchanged. Then I'll put this over. We're going to go x plus 4 over 4, and then minus x plus 4 over 16. So the idea is that now that I have this set up, I have a denominator of 1 here, 4 here, and 16 here. So you would say, what is the least common denominator when you consider those 3 guys there? What's the least common multiple of those 3 numbers? So 16, 4, and then 1. We know 1 is really irrelevant in this calculation, but I'm just doing that for clarity. But basically, the LCM, or the least common multiple of 4 and 16, is going to be 16. So the least common denominator here would be 16. So I'm going to use that to multiply by the numerator and denominator of the complex rational expression. So in other words, what I'm going to do is say I have 16 multiplied by this quantity x plus 4. You can put over 1. I'll probably just drop it at this point. Let's put this over. You're going to have 16 times this quantity x plus 4 over 4. And then minus, you're going to have 16 times this quantity x plus 4 over 16. Now for these problems, if you're really good at factoring and you understand the concepts, I would hold off on doing a lot of simplifying until you see if there's something you could factor out. Of course, I could go through and say, okay, 16 times x is 16x, then plus 16 times 4 is 64. But let's just hold off on that and see if there's a better strategy. For this guy down here, I can divide 16 by 4 and get 4. Let's just write that. And I can divide 16 by 16, that's 1. Now, do you see something that I can do without going through and doing all this distributing and things like that? Well, I want you to notice that you have this x plus 4 here and this x plus 4 here. Can I legally factor that out? Absolutely. So let me write this as 16 times the quantity x plus 4. I'm going to factor this out. Okay, so I'm going to put this out here. And just in front of a set of parentheses, what's going to go inside? Well, I'm just going to have the 4 here. And then minus, this is gone. I just pulled this out. So this would be a 1. And basically, at this point, I can subtract here. 4 minus 1 would give me 3. So this would be 3 times the quantity x plus 4. And just like that, I'm done with my problem. I'm just going to cancel this common factor of x plus 4, and I have 16 over 3. Now, if you want to do this the other way, you can. You can go through and distribute here and go through all that stuff, but it's just going to take you a lot longer. I think if you're really good at factoring, this is the way to go. Okay, for problem number 2, let's scroll down here a little bit. We've got 3 over x minus x squared over 9, and this is over 5. I'm just going to write this again for clarity as 5 over 1. You don't need to do that, but it's just something I like to do. So I have a denominator of x, and then 9, and then 1. So what's the LCD? In this case, it's just 9 times x. So I'm going to multiply that by the numerator and denominator of this complex rational expression. So I'm going to multiply 9x times 3 over x, and then minus, I'm going to have x squared over 9 times 9x, and this will be over, we'll have 5 multiplied by 9x. Okay, so let's see what we can do here. I'm going to cancel this x with this x, and then I'm going to cancel this 9 with this 9. So basically, is there anything I can pull out? It doesn't look like it. So let's proceed and just do our normal steps here. 9 times 3 would be 27. And then minus, you would basically just have x squared times, this x over here is not canceled. So that would be x cubed. And then this over, 5 times 9 is 45, and then x would come along for the ride. Now, in a lot of cases, you're asked by your teacher to factor things and show that nothing's going to cancel. In this case, I know nothing's going to cancel, so I could technically leave my answer that way. But just for the sake of completeness, this guy right here, this 27, is a perfect cube. It's 3 being cubed. And then minus this x is being cubed. So I could use my formula for the difference of cubes here to factor that. Again, nothing's going to cancel, but just for the sake of completeness, let's go ahead and do that. I'm going to write this as 3. Remember, the first sign is always the same, so minus x. and then times over here, this guy right here is squared, so that would be 9. Then the second sign is always different, so plus. Then I'm going to take the product of the two, so 3x, like that, and then plus, and then the last guy here is going to be squared. Now, I would probably take the time to rewrite this because it looks a little bit awkward. So maybe you want to write x squared plus 3x plus 9. That would be a typical standard form. And for this one, I could factor out a -1 and say this is negative of, inside everything's going to change its sign. So instead of -x, I'll put +x. And then instead of +3, I'll put -3. Again, that's not something you have to do, but just something I would do to make it look a little nicer. So let's put this up here and put this over 45x. Now, as I told you, nothing is going to cancel here, but you're just doing this to show your teacher, hey, I factored things and I can't actually cancel anything. All right, let's look at problem number 3. Let's come down here. So we have x minus 1, then this is over. We have this x minus 1 over x plus 5, and then plus x squared over x minus 1. All right, so I'm going to first say this is x minus 1 over 1, and then over, I'll have x minus 1 over x plus 5, and then plus x squared over x minus 1. So what denominators do we have? We have a 1, we have an x plus 5, and an x minus 1. So what is the LCD? Well, it's just the product of these two guys here, this x plus 5 times this x minus 1. So let's go ahead and say this is going to be multiplied by the quantity x plus 5 times the quantity x minus 1. This will be over the quantity x plus 5 times the quantity x minus 1. All right, so let's go ahead and set this up. We have this guy times this guy. Now, I think we can probably just write out that this equals, we'll have this x minus 1. And you can write quantity squared if you want here. Let's go ahead and do that. And then times, you're going to have this x plus 5 here. Then down in my denominator, if I multiply this by this guy right here, well, the x plus 5s are going to cancel. Right, so I would have x minus 1 times x minus 1. So you can have this x minus 1 quantity squared. And then basically I'm going to have this plus. Now I have this guy times this guy. So I'm going to have this x minus 1 cancel with this x minus 1. So I'll have x squared times the quantity x plus 5. This right here would go into what? This is the x squared minus 2 times this guy, so 2x, and then basically plus 1. And then plus, you're going to have this x squared times x, that's x cubed. And then plus 5 times x squared is 5x squared. Now I can simplify this. I would have x cubed. And then you have x squared plus 5x squared. That's going to be plus 6x squared. And then you're going to have minus 2x. And then you're going to have plus 1. So let me erase this and this like this. And bring this up here. For right now, if this guy was going to simplify, well, then it must be true that x plus 5 would be a factor, or x minus 1 would be a factor. I'm just going to tell you in advance that it's not going to be, just to save a little bit of time. But for right now, let's just leave our answer with the x minus 1 quantity squared times the quantity x plus 5. So that's going to be factored up here. In the denominator, I'll just leave this as x cubed plus 6x squared minus 2x plus 1. All right, let's look at problem number 4. So we're going to have this 4 over 3x plus 3 plus x plus 1 over x minus 1. And then this is over. We have the 16 over x minus 1 plus 16 over x plus 1. So my denominators here, you have x plus 1 and you have x minus 1. So x plus 1 and you have x minus 1. Now this 3x plus 3 is really 3 times the quantity x plus 1. So you also have this factor of 3 that needs to go in there. Okay, let's go ahead and put this like this. And it's going to be really hard to fit this on the screen, but I'm going to try my best. So let me put equals here. And we'll just start with this times this. So we know that basically this guy factors into this guy. So those are going to cancel. And you would have this 4 times this quantity x minus 1. So 4 times the quantity x minus 1, then plus. The next one we come across, the x minus 1 would cancel with the x minus 1. So essentially you would have 3 times the quantity x plus 1 being squared. So x plus 1 quantity squared. Okay, so we're done with that part. Let's come down here. So now we're multiplying by this guy over here on the left. So the x minus 1 is going to cancel. You would have 16 times 3. So that's going to be 48. And then times the quantity x plus 1. And then you have plus. This x plus 1 is now going to cancel. So you have 3 times 16, which is again 48. And then times the quantity x minus 1 here. So let's put this over like this. Let's slide down. Now, is there anything that I could factor out In the numerator and the denominator, it doesn't look like there's anything common. There's a 48 that's common. You could pull that out if you wanted to go a little bit quicker there. Let's just distribute in the numerator and see where that gets us. So we could go 4x minus 4, and then plus, you're going to have 3 times. Remember, you have to expand this first before you multiply by 3. So this is x squared plus 2x plus 1. Close that down. So this will be 3x squared plus 6x plus 3. Okay, so let's put that like that. And then let's slide this up here. And let's think about simplifying. You have 6x plus 4x, that's going to be 10x. Let's get rid of this and this. And then you have negative 4 plus 3, that's going to be negative 1. So let's write 3x squared. So 3x squared plus the 10x and then minus 1 like that. Now this guy, you would always try to factor things. You could put a 3x here and an x here. But forget about the fact that it's negative 1. With 1, it's only 1 and 1. So could you ever make that work? Remember, you would subtract there. So you have 3 times 1, that's 3. And this would be 1. So no, that would never work, right? So that's going to give you 2. And that doesn't get close. So this is not what we're looking for. This is going to be prime. Let's put this over here. Now, in this case, you could factor out the 48. I think it's a little bit quicker because you have it here and you have it here, right? You could always distribute it in, but then you have to pull it back out. It's really up to you. Some people get confused by this, so sometimes they just go the longer way. But I'm just going to pull the 48 out here. And inside, you're going to have this x plus 1. And then plus, you're going to have this x minus 1, right? Because in each case, you would have a 1 there, so you could just completely drop the parentheses. Now, once you're inside, you can just say, okay, well, x plus x is 2x, and 1 minus 1 is 0. So this is just 2x here, like this. And then 48 times 2x is just 96x. So this would be 96x. So nothing else we can do here. Remember, this doesn't factor, so this is your simplified answer. Okay, let's look at 5 now. So we have x minus 2 over x minus 1 plus x plus 1 over x plus 3. Then we're over the x plus 3 over x minus 1, and then plus x plus 1 over x plus 3. All right, so times, let's see, it looks like it's just going to be the x plus 3 times the x minus 1 for the LCD. Let's put that over here as well. And let's go ahead and crank this out. So for this first one here, the x minus 1 is going to cancel. So you're going to have x minus 2 times x plus 3 like that. And then plus, here the x plus 3s are going to cancel. So you have x minus 1 times x plus 1. Let's put this over. Let's come down here a little bit. Here, the x minus 1 is going to cancel. So you have x plus 3 quantity squared. So quantity squared, let me make the 3 better there. Then plus, here the x plus 3s are going to cancel. And you have x plus 1 times x minus 1. Okay, let's scroll down here a little bit. Let's put this here. Let's put equals. And let's see, can I pull anything out that I could cancel at this point? It doesn't look like it. You've got these two that I'm going to multiply together. So this would be x squared. And then my outer is 3x, my inner is negative 2x. So that would be basically plus x. And then my final here, negative 2 times 3 would be minus 6. And then plus over here, you'd have basically conjugates being multiplied together. So we know this is x squared and then minus 1. Okay, so x squared plus x squared is going to be 2x squared. So let's get rid of that. And then we know negative 6 plus negative 1 is minus 7. So minus 7. All right, so let's put this over. So use your formula here. This would be x squared plus 6x plus 9. And then from over here, I would just say, use my formula. This is x squared minus 1. If I put these guys together, x squared plus x squared is 2x squared. So let's get rid of that. And then basically 9 minus 1 would be 8. So you can actually factor a 2 out from this. You could say this is 2 times the quantity x squared plus 3x plus 4. But then you really can't get any further than that because there are no two integers such that the sum is 3 and the product is 4. All right, so this is our simplified answer. All right, let's look at problem number 6. So this is one that gives people a lot of trouble. So we have x plus 2 over 16 plus x plus 3 over x minus 2. This is over. We have 1/4 plus x plus 2 over x plus 3. Okay, so the LCD here, you've got 16 for x minus 2 and x plus 3. So between 16 and 4, you would use 16. And then x minus 2 and x plus 3 would just come in. So x minus 2 and then x plus 3. Again, we're going to do this for the numerator and the denominator. Let me move this up a little bit so that's more clean. And put this right here. So 16 times the quantity x minus 2 times the quantity x plus 3. Okay, so for this guy times this guy, the 16 is going to cancel. And essentially you would have x minus 2 times x plus 3 and then times this x plus 2. So then plus, let's work on this one. The x minus 2 is going to cancel. So you would have 16, and then you would have this x plus 3 times this x plus 3. So this is x plus 3. And then you could say quantity squared, but I think I'm going to write x plus 3 again, because notice that you have an x plus 3 here and an x plus 3 here. So that already tells me that I can factor something out from the numerator. Okay, so pay attention to that. All right, so for the denominator, let me scroll down a little bit so I can get this on the screen. We have 16 times this guy right here. The 16 divided by 4 would be 4. So it's basically 4 times these two guys. So 4 times you have x minus 2, and then you have x plus 3 there. And then let's go ahead and say plus. The x plus 3s are going to cancel here. So you're going to have 16 times the quantity x minus 2 times the quantity x plus 2. Okay, let's put this over here like this. So can I factor anything out from the denominator? Well, there's a 4 here and a 16 here, so I could factor out a 4. Let's put this as 4 times 4 like this. And let me go ahead and highlight that. Anything else I can pull out? I have an x minus 2 and I have an x minus 2. And it looks like that's it. So this is the way that I'm going to do it. If you want to go through and simplify and then factor out at the end, that's up to you. I just think it's double work. Let's come back down here, and I'm going to pull out the x plus 3 from this guy. So if I pulled it out from here, what would be left? You can use brackets or parentheses. I would have this x minus 2 times this x plus 2 inside, because I pulled this out. Then plus, if I pulled this out from here, I would have 16 times the quantity x plus 3. Okay, so let's close that down. Then let's put this over. Down here, if I pulled out a 4 times the quantity x minus 2, inside the parentheses, I'd have x plus 3 here. So x plus 3. You can remove the parentheses. You don't need them in this case. Then plus, I'm removing this 4 times the quantity x minus 2. So 4 times the quantity x plus 2, like this. Close that down. And let's do some simplifying inside of the parentheses and see what we get. So I'm going to keep this x plus 3 on the outside. Inside here, this is us multiplying conjugates. So remember, this formula is very easy. It's just x squared minus 4, right? First guy squared minus the second guy squared. Then plus over here, this is just 16x, and then plus 48. Looks like you can simplify by doing negative 4 plus 48. That is going to give me 44. So let's put this as 44 here. And then we can just slide these down so it fits. Close that down. For this guy, it looks like it's something you can't factor any further. So let's just leave that as it is. Then let's put this over. I have this 4 times the quantity x minus 2. Not going to do anything with that. Then inside of here, we have x plus 3. And then plus 4 times x is 4x. And then plus 4 times 2 is 8. So it looks like x plus 4x is going to give me 5x. So let's just put a 5 there and get rid of this. And then 3 plus 8 is going to give me 11. So let's write 5x plus 11 here. Now, of course, nothing is canceling here. But we always, again, want to show this for our teacher to say, hey, I got the answer and I factored everything and nothing's going to cancel. So this is usually preferred in terms of how you write your answer. All right, let's look at problem number 7. So we have 4 over x plus 3 plus x plus 1 over 3. Then this is over 3/4 minus 4/3. So I've got this x plus 3, I've got this 3, I've got this 4, and I've got this 3. So number-wise, you would just do 4 times 3. There's nothing in common. So that would give me 12. And then this guy would come along, so the x plus 3 here. And let me make the 3 better. So 12 times the quantity x plus 3. So this one will be pretty quick. This guy times this guy, well, the x plus 3s would cancel. You're going to have 12 times 4 there. I'm going to leave it in this format because you're going to end up being able to factor out a 4, and I'll show you that in a moment. So then you have plus, this guy divided by this guy is going to give me 4. And then basically times the quantity x plus 1, and then times the quantity x plus 3. This guy times this guy, so 12 divided by 4 is 3. 3 times 3 is 9. And then basically you would have times the quantity x plus 3 there. And then you have minus, you have this guy times this guy. So 12 divided by 3 is 4. And then 4 times 4 is 16. So then we're going to multiply by the quantity x plus 3. Okay, so things I can pull out that are going to make my life a lot easier. In the numerator, I can pull out a 4. In the denominator, I can pull out the x plus 3. Okay, so let's go ahead and do that. Let's come down here. Let's pull out a 4. Inside, I'm going to have 12 plus the result of this, which would be x squared. My outer is 3x. My inner is x. 3x plus x is 4x. And then the last, 1 times 3 is going to be 3. So if we simplify here, 12 plus 3 is 15. So let's erase this and put 15 here. Let me just slide this down a little bit so it matches. Let's put this over. Down here, I'm going to factor out this quantity x plus 3. So let's put this out in front. Inside, I'm going to have 9 minus 16. So 9 minus 16. You can just simplify that. That's going to be negative 7. So really, I could just write negative 7 out here like this. Let me slide this over a little bit so it looks a little bit better. Now, you don't have to do this. A lot of times, you'll put the negative up here or you'll put it out in front. It all means the same thing. So this will be your simplified answer. All right, let's look at problem 8. So we have x plus 2 over x minus 1 minus y plus 1 over 6. Then we're over y plus 1 over 6 plus 1 over 6. All right, so x minus 1, 6, 6, and 6. So the LCD there is just 6 times the quantity x minus 1. It's pretty easy. So this guy right here. This times this guy, the x minus 1s are going to cancel. So you're going to have 6 times the quantity x plus 2, and then minus. For this guy, the 6s are going to cancel. So you're going to have x minus 1, and then times y plus 1. Now, I think I need brackets here because I'm going to have to subtract this whole thing away. I was trying to see if I could factor anything out, but it doesn't look like at this point that I can. So let's put this over. Let's come down here. For this guy, the 6s are going to cancel. So you're going to have this y plus 1 times x minus 1. And then you have plus. The 6s are going to cancel, so you have x minus 1. So I know I can factor this out down here. But in the numerator, it doesn't look like I can factor anything. So just have to go through and crank out the work. So 6 times x is 6x, and then plus 6 times 2 is 12. And then I'm subtracting this whole thing away. X times y is xy. And then I'm going to have x times 1, which is plus x. Negative 1 times y, which is minus y. And then negative 1 times 1, which is minus 1. Close that down. Now, if you want to remove the parentheses, or in this case, brackets, you just change the sign of everything inside. So I'm going to get rid of this. This is minus, this is minus, this is plus, and this is plus. Now, can I simplify it all? 6x minus x is 5x. So let's put a 5x here, get rid of this. 12 plus 1 would be 13. So let's make this a 13 here. And I would probably want to reorder this. So let me write 5x. I'll write minus xy. I'll put plus y, and then I'll put plus 13. Let me get rid of this. Let me move this up. Let's look at this denominator now. So we have this quantity x minus 1 that can be pulled out. Inside, I would have y plus 1, and then what's left over here would be another 1. So this would be y plus 2, right, if I simplify. So those would be my factors there. I'm just going to tell you in advance you're not going to factor this and cancel anything. So this would be our simplified answer. All right, let's look at problem number 9. So we have this x minus 4 over 2 plus x minus 4 over 4. Then we're over. We have 2x minus 12 over x minus 4. And then minus, we have y minus 4 over 4. So for my LCD, I've got 2, 4, 4, and x minus 4. So number-wise, this is going to be a 4. And then I'm just going to have this x minus 4 quantity that's going to come along. So let's do this down here as well. And let's just multiply. For this times this, the 4 divided by 2 is 2. So this would be 2 times the quantity x minus 4, and then times the quantity x minus 4 again, so we could just square this. Then plus, here the 4s are going to cancel. So you'd have the quantity x minus 4 there being squared. So this we know is going to be able to be pulled out. You can highlight this right now. You know you can pull that out, but we'll do that in a moment. So let's put this over. We'll slide down here. Looks like this guy, the x minus 4s are going to cancel. So what you're going to get is 4 times the quantity 2x minus 12 here. But you could factor a 2 out from this. Really, if I pulled out a 2, I'll say this is times 2 here. Get rid of this 2 here and put this as a 6 here. And then I'll go ahead and put minus here. Let's put some brackets. The 4s are going to cancel. I'll have y minus 4 here. And then I'll have x minus 4 here. Close that down. Okay, let's look at the numerator now. We see that we can factor out this x minus 4 quantity squared. So let's go ahead and say we have the x minus 4 quantity squared. Inside the parentheses, I would have that 2. And then plus, if I'm pulling this out, there's a 1 there. So 2 plus 1 is going to give me 3. So really, I can say this is 3 times this x minus 4 quantity squared. Okay, so the numerator is done. Can't really do anything else with that. For the denominator, it doesn't look like there's anything we can really pull out. We just have to go through and crank out the simplification. So 2 times 4 is 8, then times the quantity x minus 6. Then we're subtracting away. This guy would be xy. The outer would be minus 4y. The inner would be minus 4x. And final, or the last terms, would be plus 16. Okay, so to remove the brackets, remember, you want to basically change the sign of everything inside. So let's go ahead and write, this is 3 times the quantity x minus 4 being squared. This is over. We have 8 times the quantity x minus 6. And I'll distribute that in a minute. So we'll go minus xy. We'll go plus 4y. We'll go plus 4x. And then we'll go minus 16. So I'm just changing the sign of everything inside to drop those brackets. Now this is going to be 8x minus 48. So 8x minus 48. So let's see what we have here. I'm going to put equals there. I'm just going to copy this one more time. So 3 times the quantity x minus 4 being squared. Doesn't look like anything's going to cancel with that anyway. Down here, 8x plus 4x is going to be 12x. Let's write that first. Just going to check this and this, just so I know what I've used. So then I'm going to put minus xy next. Let me check that off. Then plus 4y next. Let me check that off. And then negative 48 minus 16 would be minus 64. Let's check those off. So this would be my simplified answer. I can't do really anything else. All right, let's look at problem number 10. This one's actually pretty easy overall. So we have the x minus 5 over y plus 6 minus x plus 3 over y plus 6. Then we're over x plus 3 over y plus 6 minus y minus 4 over y plus 6. So this one's easy because you basically have the same denominator in each case. So you can think about if I'm going to multiply by y plus 6 over y plus 6, which is the LCD, well, what's going to happen is in each case, the denominator is going to cancel out. And so you're just left with the numerator. So here I would have x minus 5, and then minus, you would have this x plus 3. And you can go ahead right now and just say, okay, well, I can subtract away x and subtract away 3. So minus x and minus 3 here. And then if you want, you could just combine like terms. X minus x, that's going to basically go away. And negative 5 minus 3 is going to be negative 8. So let's write the numerator as negative 8. So nice and simple. In the denominator down here, remember, these are going to cancel. So you'll have x plus 3 here. And then minus this guy here, this y minus 4. So this would be negative y and then plus 4 once you change the signs. So 3 plus 4 is going to be 7. So let's get rid of this and put x minus y. So x minus y and then plus 7. All right, so nothing else I can do here. So this would be my simplified answer.